Top 56 SAP ECC to SAP S/4HANA ABAP Migration Interview Scenarios. The Ultimate ABAP Scenario Reference Guide. Failure Mode Driven. This video is not a tutorial. This is not a how-to guide for writing ABAP in S/4HANA. This is a survival guide based on real project failures, real production incidents, and real interview questions faced by senior consultants and architects. SAP ECC to S/4HANA migration is not a technical upgrade. It is a failure mode migration. Most projects do not fail because developers do not know ABAP syntax. They fail because teams do not understand what silently breaks, what stops compiling, and what behaves differently at runtime. If you are preparing for an ECC to S/4HANA migration, a senior ABAP or technical architect interview, or you are already fixing broken custom code, this video is designed to be your single reference.
How this video is structured.
We do not explain every topic at the same depth. That would be inefficient and exhausting. Instead, this video follows the same intensity model used by real SAP architects during migrations.
Our presentation model.
Every scenario falls into one of two categories. 1. Full-depth scenarios, complex architectural changes where logic flow must be visualized using before and after code with scrolling and highlighting. 2. Light code scenarios, quick before and after fixes where a single syntax or API change is enough to demonstrate the solution. This approach keeps the video intense, practical, and watchable end-to-end.
The migration landscape, all categories.
We have organized the entire ECC to S/4HANA migration landscape into 10 logical categories, exactly the way real projects unfold from planning to cutover.
Categories covered in this video.
On pre-migration and strategy, why projects fail before code changes. 2. ATC and code remediation, why passing checks still fails in UAT. 3. Database survival on HANA, why it worked in ECC is dangerous. 4. The vanishing tables, why direct DB access fails. 5. Universal Journal Finance projects that technically migrated. 6. Business Partner and CVI, the #1 UAT surprise. 7. Enhancements and custom logic, why old enhancements become toxic. 8. Forms, output, and integration, late-stage breakage zone. 9. Modern ABAP, where teams over-engineer or under-engineer. 10. Runtime, security, and cutover, the go-live kill zone.
Category 1. Pre-migration and strategy.
Before fixing a single line of ABAP code, you must understand why migration projects fail even before remediation begins. Most teams jump directly into syntax errors and ATC findings. That is a fundamental mistake. This category is about mindset and mental models. It separates developers who react to errors from architects who anticipate failure modes before they occur.
Scenarios covered in this category.
1. Why custom ABAP code fails after S/4HANA migration. 2. Greenfield versus brownfield migration and its ABAP impact. 3. Difference between ECC ABAP and S/4HANA ABAP architecture. 4. Custom code inventory using CCLM. 5. Why unused Z programs must be removed before migration. 6. Simplification item catalog from an ABAP perspective. These scenarios explain why some fixes are pointless, why deletion is often more valuable than remediation, and why good migrations start with strategy, not syntax.
Scenario 1. The order by trap, the silent data killer.
You migrate a custom sales order report from ECC to S/4HANA. The program activates cleanly. There are no syntax errors and no runtime dumps. However, during UAT, business users report that some sales order totals are wrong, while others appear correct. The most dangerous part is that the report looks reliable at first glance.
The real reason for failure.
This failure is not caused by incorrect arithmetic logic. It is caused by an invalid assumption about database behavior. 1. In ECC systems running on Oracle or DB2, result sets were often returned sorted by the primary key, even when no order by clause was specified. 2. Over time, developers unknowingly relied on this implicit behavior when using control break statements such as at new and at end of. 3. SAP HANA is a column store database that retrieves data in parallel. Without explicit sorting, the order of records is non-deterministic. 4. When control break logic receives randomly ordered data, it does not dump. Instead, it produces silently incorrect business results. Here is a ABAP code showing how implicit database sorting causes silent sales order total calculation errors on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the code where the hidden problem begins. This select statement does not enforce any order. In ECC, the database often returned records grouped by VBELM by coincidence. In S/4HANA, this assumption is no longer valid. Here is the control break logic that depends entirely on sorted data. This code assumes that all line items of the same sales order arrive together. When the internal table is unsorted, this block triggers unpredictably. This code snippet outputs the calculated total. Because grouping is broken, the totals can be incomplete or inflated. The program never dumps, making this failure extremely dangerous.
The fix, the interview-winning answer.
The correct fix is about enforcing deterministic behavior in a non-deterministic execution environment. First, never rely on implicit database ordering. In S/4HANA, record order is undefined unless explicitly enforced. Second, analyze whether ordering is a functional requirement or only needed for presentation. This determines where sorting belongs. Third, when using control break logic or binary search, explicitly sort the internal table before processing. Fourth, avoid blindly adding order by to every select, as database-level sorting consumes CPU and affects scalability. Finally, document the sort as a functional requirement so future developers do not remove it as a perceived optimization. This answer demonstrates architectural thinking, performance awareness, and deep understanding of HANA execution behavior. Here is a ABAP code showing how explicit sorting restores correct sales order total calculation on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the key fix. This line of code guarantees that all line items belonging to the same sales order are grouped together before the loop starts. Here is the same control break logic as before, but now it executes deterministically because the internal table order matches the business grouping. This code snippet now produces consistent and correct totals across all environments, regardless of database execution strategy.
Follow-up 1. Why not always use order by in the select to avoid this issue?
Answer: using order by forces SAP HANA to sort the result set at the database level, which consumes CPU and memory. In high-volume systems, this can significantly impact performance. If ordering is only required for application logic, sorting in ABAP memory is usually more efficient. A senior architect always decides where sorting belongs based on scale and reuse.
Follow-up 2. Does this issue also affect read table with binary search?
Answer: yes, absolutely. Binary search assumes the internal table is already sorted by the search key. If the table is not sorted, read table may return incorrect results or sy sub rc equals 4 even when data exists. This is one of the most common silent failures after S/4HANA migration.
Follow-up 3. Curveball. Why does this issue usually appear only in production?
Answer: production systems have significantly larger data volumes, which trigger parallel execution in SAP HANA. Parallel processing makes the result order visibly random. In Dev or QA, smaller datasets may coincidentally appear ordered, masking the issue until go live.
Exclusive pro tip. ATC control break detection.
ABAP Test Cockpit can detect control break logic used without explicit sorting. Enable checks for problematic select statements to catch these issues early, before they reach UAT or production.
Scenario 2. Greenfield versus brownfield. The decision that makes or breaks your migration.
Your organization is planning an ECC to S/4HANA migration. Early in the project, leadership asks a simple question: should we do a greenfield or brownfield migration? The project team treats this as a technical choice. Months later, the project is over budget, timelines slip, and custom code remediation spirals out of control.
The real reason for failure.
This failure happens because greenfield versus brownfield is not a technical decision. It is an architectural and organizational decision. 1. Teams assume brownfield is cheaper because existing code is reused without analyzing the quality or relevance of that code. 2. Greenfield is often misunderstood as starting from scratch, when in reality it is about resetting architecture, not business logic. 3. ABAP custom code volume, data model complexity, and business process debt are not evaluated early enough. 4. The wrong choice locks the project into years of remediation, retrofit, and operational inefficiency.
Why this decision is so dangerous.
Greenfield versus brownfield defines how much technical debt you consciously choose to carry into S/4HANA. Once the migration path is chosen, reversing it is practically impossible without restarting the project. This decision affects custom code volume, testing strategy, data migration complexity, and long-term system agility.
The fix, the interview-winning answer.
A senior architect does not choose greenfield or brownfield emotionally. The decision is data-driven. First, analyze custom code usage, not just volume. Dead or unused Z programs heavily favor a greenfield approach. Second, evaluate how far current business processes deviate from SAP standard. Heavy deviation increases brownfield risk. Third, consider the future roadmap. If the organization plans major process redesign, greenfield reduces long-term cost. Fourth, assess organizational readiness. Greenfield requires stronger change management and business involvement. Finally, choose brownfield only when business continuity outweighs technical debt and remediation effort is clearly bounded. This answer shows strategic thinking, cost awareness, and long-term architectural ownership.
Follow-up 1. Why do most projects still choose brownfield even when greenfield is cleaner?
Answer: most organizations choose brownfield due to fear of business disruption and tight timelines. Brownfield feels safer politically because existing processes are preserved. However, this often shifts cost from implementation to long-term maintenance. Senior architects must explicitly explain this trade-off to leadership.
Follow-up 2. Can we mix greenfield and brownfield in the same project?
Answer: yes, and many successful projects do exactly that. Core finance or logistics may follow a brownfield approach, while peripheral or heavily customized areas are rebuilt using greenfield principles. This hybrid approach requires strong governance to avoid inconsistency.
Follow-up 3. Curveball. Why does a poor greenfield versus brownfield decision surface only after go-live?
Answer: because early project phases focus on technical conversion and testing, not operational efficiency. The real cost appears post-go-live through slow enhancements, fragile custom code, and high support effort. By then, the architectural decision is already locked.
Exclusive pro tip. Use custom code usage data, not assumptions.
Before deciding on greenfield or brownfield, run usage analysis on custom programs using SCMON or UPL. Many organizations discover that more than 40% of custom code has not been executed in years. This single insight often changes the migration strategy.
Scenario 3. ECC versus S/4HANA architecture. The mental model mismatch.
You move experienced ECC developers onto an S/4HANA project. They know ABAP well and have delivered stable systems for years. Yet, after migration, performance issues, design rework, and repeated refactoring dominate the project. The team is working hard, but progress feels slow and chaotic.
The real reason for failure.
This problem is not caused by lack of skill. It is caused by using an ECC-era mental model in an S/4HANA system. 1. ECC systems were optimized for disk-based row-store databases, where minimizing database access was the primary goal. 2. Developers were trained to pull large datasets into ABAP and process them in loops on the application server. 3. S/4HANA is built on an in-memory column store database where set-based operations and pushdown are significantly faster. 4. When ECC design patterns are reused unchanged, they actively work against the strengths of the S/4HANA architecture.
Why ECC-era design patterns break in S/4HANA?
S/4HANA fundamentally shifts where computation should happen. Logic that was previously optimized for the ABAP application server must now be evaluated for database execution. Teams that fail to adjust this mental model end up with systems that are technically converted but architecturally inefficient.
The fix, the interview-winning answer.
A senior architect explains this difference in terms of responsibility, not syntax. First, stop treating the database as a passive storage layer. In S/4HANA, the database is a compute engine. Second, push filtering, aggregation, and joins down to the database wherever possible using OpenSQL, CDS, or AMDP. Third, reserve ABAP loops for orchestration and business rules, not for mass data processing. Fourth, revisit legacy performance rules of thumb, as many ECC optimizations are anti-patterns on HANA. Finally, retrain teams to design with data volume and execution location in mind from the very beginning. This answer demonstrates architectural maturity and a correct understanding of S/4HANA execution principles.
Follow-up 1. Does this mean all ABAP logic should move to the database?
Answer: no. S/4HANA does not mean pushing everything into SQL or CDS. Business rules, validations, and orchestration logic still belong in ABAP. The key is to push data-intensive operations down while keeping business semantics readable and maintainable in the application layer.
Follow-up 2. Why do some ECC-style reports still perform well in S/4HANA?
Answer: some reports work well simply because the data volume is small or the access path is simple. This can create a false sense of correctness. Once data grows or execution becomes parallel, those same reports often degrade quickly. Architects plan for scale, not lucky performance.
Follow-up 3. Curveball. Why is this problem mostly cultural rather than technical?
Answer: because tools and syntax can be learned quickly, but mental models take time to change. Teams often measure success by syntax fixes and activation, not by architectural correctness. Without leadership reinforcing new design principles, ECC habits persist long after migration.
Exclusive pro tip. Watch for nested select loops.
One of the fastest ways to spot ECC-era thinking is nested select statements inside loops. Even if they pass ATC checks, they usually indicate missed opportunities for pushdown. Flag them early in code reviews during migration projects.
Scenario 4. Custom code inventory with CCLM. The illusion of progress.
You run custom code lifecycle management and generate a massive list of Z programs, function modules, and includes. Thousands of objects appear in the inventory. The project plan now says, remediate all custom code. Months later, the team is exhausted, timelines slip, and business value is unclear.
The real reason for failure.
The failure is not caused by lack of tooling. It is caused by misunderstanding what an inventory is meant to achieve. 1. Teams treat the CCLM inventory as a to-do list instead of a decision-making tool. 2. All custom code objects are assumed to be equally important, regardless of usage or business criticality. 3. Unused, obsolete, or rarely executed programs receive the same remediation effort as revenue-critical logic. 4. This creates the illusion of progress, while consuming time on code that should never be migrated.
Why inventory without classification fails?
CCLM answers the question, what do we have? But migration success depends on answering what do we actually need. Without classification, usage context, and ownership, inventory-driven remediation becomes an expensive exercise in busywork rather than architectural improvement.
The fix, the interview-winning answer.
A senior architect uses CCLM to reduce scope, not inflate it. First, classify custom code by usage frequency using tools like SCMon or UPL, not by object count. Second, separate business-critical code from historical or convenience reports that can be retired. Third, assign business ownership to critical custom code so remediation decisions are not purely technical. Fourth, delete unused custom code early to reduce ATC findings, testing effort, and regression risk. Finally, treat CCLM as an input to scope reduction, not as a checklist for remediation. This answer demonstrates cost control, architectural ownership, and practical migration leadership.
Follow-up 1. Why is deleting custom code before migration so strongly recommended?
Answer: because every line of code you keep must be remediated, tested, transported, and supported after go live. Unused code adds zero business value but multiplies technical risk. Deleting early reduces ATC noise and shortens testing cycles significantly.
Follow-up 2. What resistance do teams usually face when proposing code deletion?
Answer: the most common resistance is fear of breaking unknown dependencies. Teams worry that someone might still be using the code. This is why usage data and business sign-off are critical. Data-driven deletion decisions are far easier to defend than assumptions.
Follow-up 3, curveball. Why does excessive custom code remediation often delay go-live?
Answer: because remediation increases testing scope non-linearly. Every fixed object requires unit testing, integration testing, and regression testing. Projects that try to fix everything often spend more time testing unused code than validating real business processes.
Exclusive pro tip. Use CCLM as a decommissioning tool.
Instead of asking how much custom code you need to fix, ask how much you can safely delete. Teams that use CCLM to aggressively decommission unused code consistently reduce migration timelines and post-go-live support effort.
Scenario 5. Removing Z programs, the dead weight problem.
You inherit an ECC system with thousands of Z programs, reports, and utilities accumulated over many years. During migration planning, the team decides to technically convert everything to be safe. As the project progresses, ATC findings explode, testing effort multiplies, and confidence in the system steadily drops.
The real reason for failure.
The failure is not technical. It is caused by fear-driven decision-making. 1. Teams assume that keeping all custom code is the safest option, even when business usage is unknown. 2. Unused Z programs silently increase remediation, testing, and regression scope. 3. Legacy utilities often depend on obsolete tables, unreleased APIs, or implicit database behavior. 4. By migrating everything, teams carry historical technical debt directly into S/4HANA.
Why dead code is more dangerous than broken code.
Broken code fails visibly and gets fixed. Dead code fails silently by consuming time, budget, and attention. In S/4HANA migrations, the biggest delays often come from remediating code that no one actually needs. Architects focus on reducing surface area before improving quality.
The fix, the interview-winning answer.
A senior architect treats deletion as a first-class migration activity. First, identify unused Z programs using runtime usage data rather than assumptions. Second, involve business owners to confirm whether rarely used programs still provide value. Third, decommission obsolete reports and utilities before running ATC or remediation. Fourth, document deleted objects to build organizational confidence and traceability. Finally, treat code deletion as risk reduction, not as a loss of functionality. This answer shows ownership, cost awareness, and the courage to simplify.
Follow-up 1. Why are teams so reluctant to delete Z programs?
Answer: because deletion feels irreversible and risky, especially in systems with poor documentation. Teams fear unknown dependencies and potential business backlash. Without usage data and business sign-off, technical teams default to keeping everything, even when it is clearly obsolete.
Follow-up 2. Is it ever acceptable to migrate unused Z programs and delete them later?
Answer: technically yes, but it is a poor strategy. Migrating unused code increases remediation and testing cost upfront. It also increases the likelihood that obsolete code accidentally survives into production. Deleting early is always cheaper than deleting after go-live.
Follow-up 3, curveball. How do you handle a business user who insists a rarely used report must stay?
Answer: ask the business to classify the report as critical, optional, or obsolete. If it is critical, assign ownership and testing responsibility. If it is optional, consider rebuilding it later using CDS or analytics tools. This reframes the discussion from emotion to accountability.
Exclusive pro tip. Freeze Z development early.
Once the migration scope is defined, freeze new Z development as early as possible. Continuing to create custom code during migration undermines deletion efforts and constantly shifts the remediation baseline.
Scenario 6. The simplification item catalog. The ignored warning system.
Your migration project progresses smoothly through sandbox and development. ATC issues are being fixed, transports are moving, and timelines look stable. Then, during integration testing or just before cutover, unexpected functional issues appear. Entire business processes behave differently, even though the code compiled successfully.
The real reason for failure.
This failure occurs because the simplification item catalog was treated as documentation instead of a mandatory design input. 1. The simplification item catalog describes functional and technical changes that cannot be detected by syntax checks alone. 2. Many items require configuration changes, process redesign, or business decisions, not just code remediation. 3. Teams assume that a TC or sum will catch all breaking changes, which is incorrect. 4. When simplification items are ignored early, their impact surfaces late when changes are expensive and risky.
Why syntax checks are not enough.
A TC validates technical correctness, but it does not validate business semantics. The simplification item catalog captures changes in data models, process behavior, and functional assumptions. These changes often require architectural decisions that must be made before development starts.
The fix, the interview-winning answer.
A senior architect treats the simplification item catalog as a design authority, not a reference document. First, review relevant simplification items during the explore or prepare phase, not after development begins. Second, classify each item as technical, functional, or organizational to assign correct ownership. Third, identify which items require business decisions rather than technical fixes. Fourth, reflect simplification impacts in solution design documents and testing strategy. Finally, track simplification items as project risks, not as optional reading. This answer demonstrates proactive risk management and architectural foresight.
Follow-up 1. Why do teams often underestimate the simplification item catalog?
Answer: because it looks like documentation rather than an executable checklist. Teams focus on code and configuration tasks they can immediately action. Simplification items often require cross-team coordination, which makes them easier to postpone until it is too late.
Follow-up 2. How do you decide which simplification items are critical?
Answer: start with items that affect core business processes, data persistence, or reporting. Anything that changes how data is stored or interpreted should be treated as high risk. Less critical items can be scheduled later, but core process changes must be addressed early.
Follow-up 3. Curveball. Why do simplification issues often appear after go-live?
Answer: because many simplification changes affect edge cases and infrequent processes. These are rarely tested thoroughly before go-live. Once real production usage begins, these gaps surface quickly, often under business pressure.
Exclusive pro tip. Link simplification items to test cases.
For every high-impact simplification item, create at least one explicit test case. This ensures the change is validated functionally, not just assumed correct based on technical conversion.
Section 1 complete. Why most migrations fail before code changes.
Section 1 was not about syntax or tools. It was about mindset. We covered the strategic and architectural decisions that quietly determine whether an S/4HANA migration will succeed or struggle. Teams that skip these conversations often end up fixing the same problems repeatedly, without understanding why they exist. By this point, a senior architect should already know what to delete, what to redesign, and what not to touch. Only after these decisions are made does it make sense to talk about remediation tools and code fixes.
From strategy to execution.
Now that the migration scope and architectural direction are clear, we move into execution. This is where most teams spend the majority of their time, and where many mistakes are made due to misunderstanding the tooling.
Section 2. ATC and custom code remediation.
This section focuses on the tools and techniques used to make custom code technically compatible with S/4HANA. The goal is not to blindly clear errors, but to understand what the tools are actually telling you and what they are not. Senior consultants do not treat ATC findings as a to-do list. They treat them as signals that must be interpreted, prioritized, and sometimes challenged.
Scenarios covered in this category.
7. ATC versus Code Inspector SI. 8. Using ADT quick fixes for mass remediation. 9. Most common ATC errors after S/4HANA conversion. 10. Fixing obsolete ABAP statements. 11. Handling unreleased SAP APIs. 12. False positives using pragmas and pseudo comments. 13. Priority 1 versus Priority 2 findings. These scenarios separate teams that clear checks from architects who understand risk.
Scenario 7, ATC versus SI. Why using the wrong tool wastes months.
A project team runs Code Inspector because it is familiar and easy to execute. The results look manageable. After moving to S/4HANA, the same code suddenly fails activation, behaves unpredictably, or breaks SAP support rules. The team feels blindsided.
The real reason for failure.
This failure occurs because Code Inspector and ATC serve very different purposes. 1. Code Inspector was designed for classic ECC systems and focuses mainly on syntax, security, and basic performance. 2. ATC is S/4HANA aware and includes checks for database behavior, released APIs, and future compatibility. 3. Teams assume SI coverage equals migration readiness, which is incorrect. 4. Critical S/4HANA specific issues are invisible unless ATC is configured correctly.
Why ATC is mandatory for S4HANA.
ATC is not just a replacement for SI. It is a central governance tool that enforces SAP's S/4HANA rules. It understands database semantics, released object contracts, and future upgrade constraints. SI does not.
The fix, the interview-winning answer.
A senior architect explains this difference in terms of risk and supportability. First, use ATC as the primary remediation tool for S/4HANA migrations, not Code Inspector. Second, configure ATC with the correct S/4HANA check variant to surface database and API violations. Third, use SI only for legacy quality checks that are not migration-specific. Fourth, centralize ATC execution to ensure consistent results across all systems and teams. Finally, treat unresolved ATC findings as architectural risks, not just technical defects. This answer demonstrates tool mastery and long-term system ownership.
Follow-up 1. Can we run both ATC and SI together?
Answer: yes, and many mature teams do. SI can still be useful for classic quality checks, while ATC covers S/4HANA-specific risks. The key is understanding that SI cannot replace ATC for migration readiness. Each tool has a distinct purpose.
Follow-up 2. Why do some teams resist switching fully to ATC?
Answer: because ATC findings are often more numerous and harder to interpret. They expose architectural issues rather than simple syntax errors. Teams under time pressure sometimes prefer SI because it produces fewer findings, even if those findings are incomplete.
Follow-up 3. Curveball. Why does SAP support care whether we use ATC or SI?
Answer: because ATC enforces SAP's released object and upgrade rules. Code that passes SI but violates ATC checks can break during upgrades or support packages. SAP expects customers on S/4HANA to follow ATC governance to remain support compliant.
Exclusive pro tip. Central ATC system setup.
Set up a central ATC system to run checks across all development landscapes. This ensures consistent results, avoids local configuration drift, and gives architects a single source of truth for remediation status.
Scenario 8. ADT quick fixes, the fastest way to fix code and break understanding.
Your team starts running ATC checks in Eclipse ADT. Hundreds of findings appear. A developer presses Ctrl+1, applies quick fixes in bulk, and the error count drops dramatically. The project looks healthy again. Weeks later, subtle bugs and performance regressions start appearing.
The real reason for failure.
The failure is not caused by quick fixes themselves, but by blind trust in automation. 1. ADT quick fixes change syntax, but they do not explain architectural intent. 2. Developers often apply fixes without understanding why the original code was flagged. 3. Some quick fixes are syntactic improvements, while others subtly change behavior. 4. When applied blindly, quick fixes can introduce logical or performance issues. Here is a BAP code before applying an ADT quick fix. ATC finding. Disclaimer: always test code in a non-production environment. This is the legacy syntax. It works, but it is verbose. The ATC flags this as an obsolete statement because modern ABAP prefers direct assignment. Here is a BAP code after applying the ADT quick fix. Ctrl+1. Disclaimer: always test code in a non-production environment. The quick fix automatically converts the syntax. While this specific change, move to assignment, is safe, other quick fixes, like inserting order by or modifying OpenSQL, can drastically change performance profiles. That is why we review them.
Why this matters more than it looks.
This example looks trivial, but it represents a much larger pattern. ADT quick fixes are powerful because they encode SAP's recommended direction. However, they do not replace architectural judgment. Knowing when a fix is cosmetic versus behavioral is what separates senior developers from junior ones.
The fix, the interview-winning answer.
A senior architect uses quick fixes as an accelerator, not as a decision maker. First, use ADT quick fixes to speed up remediation, not to replace understanding. Second, review each category of quick fix to determine whether it is syntactic or behavioral. Third, avoid bulk application of fixes in critical business logic without review. Fourth, combine quick fix usage with code reviews to ensure intent is preserved. Finally, treat quick fixes as guidance from SAP, not as unquestionable truth. This answer shows balance between efficiency and architectural responsibility.
Follow-up 1. Is it safe to apply ADT quick fixes in bulk?
Answer: it depends on the type of finding. Pure syntax modernizations are usually safe. Fixes related to database access, API usage, or semantics should be reviewed carefully. Bulk fixes without review often save time initially but cost more during testing.
Follow-up 2. Why do quick fixes sometimes change runtime behavior?
Answer: because some fixes do more than change syntax. They may replace obsolete constructs, enforce strict typing, or alter how data is accessed. Without understanding the original intent, these changes can subtly affect logic or performance.
Follow-up 3. Curveball. Why do interviewers ask about quick fixes at all?
Answer: because quick fixes reveal how a developer thinks under pressure. Anyone can press Ctrl+1. Interviewers want to know whether you understand what changed, why it changed, and when you would not accept the fix.
Exclusive pro tip. Filter ATC findings before using quick fix.
Before applying quick fixes, group ATC findings by category. Fix pure syntax issues first, then review database and API-related findings separately. This prevents accidental behavior changes in critical code paths.
Scenario 9. Common ATC errors. The same mistakes every project repeats.
After running ATC for the first time, the team is overwhelmed. Hundreds of errors appear across different programs. Developers start fixing issues randomly just to reduce the error count. The ATC dashboard slowly turns green, but confidence in the codebase does not improve.
The real reason for failure.
The failure happens because teams focus on quantity instead of pattern recognition. 1. Most ATC findings fall into a small number of recurring error categories. 2. Teams treat each finding as unique instead of recognizing common root causes. 3. Developers fix symptoms without understanding why the same errors keep appearing. 4. Without classification, remediation becomes repetitive and inefficient. Here is ABAP code triggering a common ATC error. Select without order by. Disclaimer: always test code in a non-production environment. Here is the code triggering a very common ATC finding. The select statement does not enforce ordering, which can lead to non-deterministic behavior in S/4HANA when the result is processed later. Here is ABAP code after fixing the ATC error with explicit intent. Disclaimer: always test code in a non-production environment. This line of code explicitly enforces ordering. The ATC error is resolved, and the developer has clearly documented intent through the SQL statement.
Why these errors keep coming back?
Most ATC errors are not complex. They repeat because legacy coding patterns are reused across hundreds of programs. Without recognizing these patterns early, teams fix the same mistake again and again instead of addressing it systematically.
The fix, the interview-winning answer.
Senior architect treats ATC results as data, not noise. First, classify ATC findings by category instead of by program. Second, identify the top recurring error types and address them systematically. Third, educate the team on why these errors occur, not just how to fix them. Fourth, create reusable remediation patterns or templates for common findings. Finally, measure remediation progress by risk reduction, not by error count. This answer demonstrates efficiency, pattern recognition, and architectural leadership.
Follow-up 1. Should we aim to eliminate all ATC errors?
Answer: not necessarily. Some findings represent low risk or acceptable technical debt. The goal is to eliminate high-risk findings that affect correctness, performance, or upgrade safety. Senior architects focus on impact, not perfection.
Follow-up 2. Why do the same ATC errors appear in many programs?
Answer: because legacy coding standards were copied and reused for years. Patterns like select or missing order by were once acceptable. ATC exposes these patterns at scale, which is why the error count feels overwhelming initially.
Follow-up 3. Curveball. Why does ATC sometimes flag code that has worked for decades?
Answer: because ATC evaluates future risk, not past success. Code that worked in ECC may break under parallel execution, large data volumes, or future upgrades. ATC enforces forward compatibility, not historical correctness.
Exclusive pro tip. Export ATC results to spot patterns.
Export ATC findings to a spreadsheet or dashboard and group them by check category. Most projects discover that a small number of error types account for the majority of findings. Fixing those first accelerates remediation dramatically.
Scenario 10. Obsolete statements, the move trap.
During ATC remediation, developers encounter hundreds of warnings about obsolete statements. Many treat these as cosmetic issues and apply fixes mechanically. After go live, subtle data issues and type-related bugs start appearing, even though the code base looks modernized.
The real reason for failure.
This failure happens because obsolete statements hide implicit behavior that modern ABAP no longer tolerates. 1. Legacy statements like move allow implicit type conversions without explicit intent. 2. Developers relied on these conversions for years without realizing the risks. 3. Modern ABAP enforces stricter typing to prevent silent truncation and data loss. 4. Blindly modernizing syntax without understanding intent can introduce new defects. Here is ABAP code using an obsolete move statement, ATC finding. Disclaimer: always test code in a non-production environment. Here is the code triggering the ATC warning. The move statement allows implicit type conversion from character to packed number, which may silently fail or truncate data depending on content. Here is ABAP code after replacing move with explicit assignment. Disclaimer: always test code in a non-production environment. This assignment uses modern ABAP syntax. It makes type conversion explicit and allows stricter checks at runtime and during syntax validation.
Why obsolete syntax is a migration smell.
Obsolete statements are rarely isolated problems. They usually indicate legacy assumptions about typing, data formats, or runtime behavior. In S/4HANA, these assumptions become liabilities because stricter checks exist to protect data integrity.
The fix, the interview-winning answer.
A senior architect treats obsolete syntax as a signal to reevaluate intent. First, identify why the obsolete statement was used originally, not just how to replace it. Second, check whether implicit conversions were relied upon for business logic. Third, replace obsolete statements with explicit assignments that document intent. Fourth, validate edge cases where data may not conform to expected formats. Finally, treat syntax modernization as a correctness exercise, not a cosmetic cleanup. This answer demonstrates attention to data integrity and long-term code safety.
Follow-up 1. Is replacing move with equals always safe?
Answer: not always. While the syntax change is straightforward, the underlying behavior may differ if implicit conversions were previously relied upon. Senior developers validate assumptions by testing edge cases and data boundaries before declaring the fix safe.
Follow-up 2. Why does ATC care about obsolete statements at all?
Answer: because obsolete statements often bypass modern checks and safeguards. ATC flags them to reduce future upgrade risk and enforce clearer intent. This makes the codebase more predictable and easier to maintain long-term.
Follow-up 3. Curveball. Can obsolete syntax still exist in S/4HANA standard code?
Answer: yes, in some edge cases for backward compatibility. However, customer code is expected to follow modern standards. SAP tolerates legacy constructs internally, but expects customers to align with forward-compatible practices.
Exclusive pro tip. Search for move as a pattern, not a warning.
Instead of fixing move statements one by one, Scan the codebase for recurring conversion patterns. This often reveals broader data modeling issues that should be addressed during migration.
Scenario 11. Unreleased APIs, the supportability time bomb.
After migration, a custom program compiles and runs correctly. Functional testing passes. Weeks later, ATC flags a critical finding related to unreleased SAP objects. The team is confused, nothing is broken, yet the finding is marked as high risk.
The real reason for failure.
The failure is not functional, it is contractual. 1. Developers directly call SAP internal function modules or classes that were never released for customer use. 2. These objects are not part of SAP's compatibility contract and can change or disappear without notice. 3. Code Inspector often allows these calls, but ATC flags them as upgrade and support risks. 4. The system works today, but future upgrades can break the logic without warning. Here is ABAP code calling an unreleased SAP function module. ATC finding. Disclaimer: always test code in a non-production environment. Here is the code calling an internal SAP function module. Although it may work today, ATC flags this because the function module is not released for customer use and is not upgrade safe. Here is ABAP code using a released API instead of an internal function module. Disclaimer: always test code in a non-production environment. This code snippet uses a released BAPI. Released APIs are part of SAP's stability contract and are safe to use across upgrades and support packages.
Why released APIs matter in S/4HANA?
S/4HANA enforces a clear separation between SAP internal implementation and customer extensions. Released APIs define a stable contract. Using unreleased objects tightly couples your code to SAP internals, which is unacceptable in long-term enterprise systems.
The fix, the interview-winning answer.
A senior architect frames this as a governance and supportability issue. First, never use SAP objects that are not explicitly released for customer use. Second, treat ATC unreleased API findings as mandatory fixes, not recommendations. Third, replace internal calls with released BAPI classes or CDS views. Fourth, accept functional limitations of released APIs instead of bypassing them. Finally, design custom logic to survive upgrades, not just to pass today's tests. This answer demonstrates long-term ownership and alignment with SAP's extension strategy.
Follow-up 1. Why did SAP allow access to these internal objects in ECC?
Answer: ECC did not enforce strict API contracts, and many internal objects were technically callable. Over time, customers began relying on them. S/4HANA corrects this by enforcing clear boundaries to protect upgrade stability and cloud readiness.
Follow-up 2. What if no released API provides the required functionality?
Answer: in that case, architects must redesign the solution or raise a requirement through SAP channels. Bypassing the contract is not acceptable. Sometimes this leads to functional compromises, but those are preferable to unstable systems.
Follow-up 3. Curveball. Why does this matter more in S/4HANA Cloud?
Answer: because S/4HANA Cloud upgrades are mandatory and frequent. Any reliance on unreleased objects will break quickly. On-premise systems may survive longer, but the architectural risk is the same.
Exclusive pro tip. Use the API release check early.
Run the API release check in ATC as early as possible. Fixing unreleased API usage late in the project often requires significant redesign, not just code changes.
Scenario 12. False positives in ATC, the pragmas debate.
During ATC remediation, the team encounters findings that appear incorrect. The code is intentional, reviewed, and behaves correctly in production. Developers either ignore the findings or suppress them everywhere without discussion. Over time, the ATC report becomes meaningless.
The real reason for failure.
The failure is not caused by ATC inaccuracies. It is caused by misuse of suppression mechanisms. 1. ATC checks are rule-based and cannot always infer business intent. 2. Some findings are technically correct but contextually irrelevant. 3. Teams suppress findings globally instead of documenting intent locally. 4. Overuse of pragmas hides real problems and erodes trust in ATC. Here is ABAP code triggering an ATC finding. that is contextually acceptable. Disclaimer: always test code in a non-production environment. Here is the code triggering the ATC finding. ATC cannot verify at this point whether the internal table is sorted, so it flags a potential runtime risk. Here is ABAP code with a justified pragma to suppress a false positive. Disclaimer: always test code in a non-production environment. This pragma explicitly documents that the table is sorted before the binary search. It tells ATC that the developer has intentionally ensured correctness.
Why pragmas are a double-edged sword.
Pragmas are not a way to silence tools. They are a way to document intent for both ATC and future maintainers. Used correctly, they improve signal quality. Used carelessly, they mask real defects and undermine governance.
The fix: the interview-winning answer.
A senior architect treats pragmas as design documentation, not shortcuts. First, confirm that the ATC finding is truly a false positive by validating runtime behavior. Second, fix the code explicitly where possible instead of suppressing the finding. Third, use pragmas only when the intent cannot be expressed clearly in code. Fourth, apply pragmas locally and narrowly, never globally. Finally, review pragma usage regularly to ensure it still reflects reality. This answer demonstrates discipline, intent, and respect for automated governance.
Follow-up 1. When should pragmas be avoided entirely?
Answer: pragmas should be avoided when the underlying issue can be resolved with clearer or safer code. If a refactor can remove the finding, that is always preferable. Pragmas are a last resort, not a first response.
Follow-up 2. Why do some projects ban pragmas altogether?
Answer: because uncontrolled pragma usage can hide serious problems. Some teams prefer strict remediation to force better design. However, this approach can also create unnecessary noise if not balanced with context.
Follow-up 3. Curveball. How can pragmas become technical debt?
Answer: if the assumptions behind a pragma change, the suppression becomes incorrect. Over time, code evolves but pragmas remain. Without regular review, they can mask defects that reappear only during upgrades or performance spikes.
Exclusive pro tip. Track pragmas as architectural exceptions.
Maintain a lightweight register of pragmas used in critical code paths. Treat them like approved exceptions. This makes future audits, upgrades, and refactoring far safer.
Scenario 13. Priority 1 versus Priority 2 ATC findings. The remediation trap.
After running ATC, the remediation backlog explodes. Hundreds of findings are labeled Priority 1 and Priority 2. The project manager demands that everything be fixed before go live. Developers comply, but timelines slip and fatigue sets in. Despite massive effort, risk does not seem to decrease proportionally.
The real reason for failure.
The failure is caused by misunderstanding what ATC priorities actually represent. 1. Priority levels indicate technical severity, not business impact. 2. Not all Priority 2 findings pose real operational or upgrade risk. 3. Teams often treat ATC priorities as absolute rules instead of decision inputs. 4. This leads to over-remediation and wasted effort on low-impact issues.
Why ATC priority is not the same as business risk.
ATC evaluates code against technical rules, not business workflows. A Priority 1 finding in a rarely used report may be less risky than a Priority 2 finding in a high-volume financial interface. Architects must translate technical findings into business-aware decisions.
The fix: the interview-winning answer.
A senior architect prioritizes findings based on impact, not fear. First, treat Priority 1 findings as mandatory fixes but still validate business context. Second, review Priority 2 findings and assess their runtime, data volume, and process impact. Third, focus remediation on code paths executed in core business processes. Fourth, formally accept or defer low-impact findings with documented justification. Finally, align remediation priorities with testing scope and go-live risk. This answer demonstrates judgment, not blind compliance.
Follow-up 1. Is it acceptable to go live with unresolved Priority 2 findings?
Answer: yes, if the risk is understood and accepted. Many Priority 2 findings are informational or related to edge cases. What matters is transparency and documentation, not zero findings. Senior teams manage risk rather than chasing perfection.
Follow-up 2. Why do auditors sometimes push to fix all ATC findings?
Answer: auditors focus on rule compliance, not operational reality. Without architectural context, they assume all findings are equal. It is the architect's responsibility to translate technical results into business-relevant risk discussions.
Follow-up 3, curveball. What is the danger of fixing low-impact findings too early?
Answer: it diverts effort away from critical risks and increases regression scope. Every change must be tested. Over-remediation can actually increase instability by introducing unnecessary changes into stable code paths.
Exclusive pro tip. Create a remediation decision matrix.
Classify ATC findings using both technical priority and business impact. A simple matrix helps teams focus effort where it actually reduces go-live risk and prevents endless debates.
Section 2 complete. Tools don't fix systems, architects do.
Section 2 was about execution discipline. ATC, quick fixes, and remediation tools are powerful, but only when guided by judgment. Teams that blindly chase green dashboards often create more risk than they remove. Mature teams interpret findings, prioritize intelligently, and understand the intent behind every fix. At this point, the code is technically compliant. But technical compliance alone does not guarantee performance, scalability, or correctness in S/4HANA.
The real battlefield, the database.
Now we move to the layer where most ECC assumptions quietly collapse: the database. This is where many migrations technically succeed but functionally fail under real load.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Section 3, Database Survival on SAP HANA.
This section focuses on how SAP HANA fundamentally changes data access, execution order, and performance behavior. These are not syntax problems. They are architectural shifts that directly affect correctness and scalability. Many production defects after S/4HANA migration originate here, not because developers wrote bad code, but because the database no longer behaves the way ECC trained them to expect.
Scenarios covered in this category.
14. Select star on column store databases. 15. Implicit sorting assumptions. 16. For all entries empty table trap. 17. Why secondary indexes disappear. 18. Select single verses up to 1 rows. 19. Code pushdown versus ABAP loops. These scenarios explain why reports pass tests but fail in production.
Scenario 14. Select star on SAP HANA, the performance time bomb.
You migrate a heavily used finance report from ECC to S/4HANA. The report calculates company code totals during month-end close. It activates cleanly, passes unit testing, and produces correct numbers. However, during the first real close cycle, runtime increases from seconds to several minutes, blocking business users and creating escalation calls.
The real reason for failure.
This failure is not caused by SAP HANA being slow. It is caused by abusing a column store database as if it were row-based. 1. ECC systems typically ran on row store databases, where reading unused columns had limited overhead. 2. Developers used select star out of convenience, assuming the database cost was acceptable. 3. SAP HANA stores data column-wise and optimizes execution by reading only required columns. 4. Select star forces HANA to read every column, disabling column pruning and exploding memory and CPU usage. Here is a ABAP code showing how select star causes massive performance degradation in a finance report on SAP HANA. Disclaimer: always test code in a non-production environment. Here is the code where the architectural mistake begins. Select star forces SAP HANA to read every column from BSEG, including many that are never used by the report. This code snippet shows that aggregation is performed in ABAP after all data has already been transferred from the database to the application server. Here is the actual business logic. Only one numeric column is needed, yet dozens of columns were fetched unnecessarily, multiplying execution cost.
The fix, the interview-winning answer.
The correct fix is not syntax optimization. It is architectural pushdown. First, never use select star in S/4HANA unless every column is functionally required. Second, explicitly select only the fields required for business logic or presentation. Third, push aggregations to the database to leverage in-memory processing. Fourth, minimize data transfer between SAP HANA and the ABAP application server. Finally, design reports assuming large data volumes and parallel execution. This answer demonstrates understanding of column store behavior and scalable design. Here is a ABAP code showing how code pushdown and column pruning restore finance report performance on SAP HANA. Disclaimer: always test code in a non-production environment. Here is the key architectural change. Aggregation is pushed entirely to the database, allowing SAP HANA to execute it in memory on compressed column data. This code snippet shows that only final results are transferred to the application server, eliminating massive data movement. Here is the output logic. By pushing the calculation down, this result renders instantly, whereas the previous loop approach would have timed out.
Follow-up 1. Why did this report appear fine during testing?
Answer: test systems typically have far smaller data volumes and warm caches. Under those conditions, select star may not show visible performance issues. Production month-end processing triggers large scans and parallel execution, exposing the real cost.
Follow-up 2. Is select star ever acceptable on SAP HANA?
Answer: only in rare cases, such as very small customizing tables or exploratory debugging. In productive reports and interfaces, select star should be treated as an architectural smell and actively avoided.
Follow-up 3. Curveball. Why can select star be more dangerous on HANA than on Oracle?
Answer: because HANA's strength is column pruning and in-memory compression. Select star disables these optimizations. On row store databases, the penalty was smaller. On HANA, it directly attacks the database's core advantage.
Exclusive pro tip. SD05 column analysis.
Run SD05, SQL trace, and review the column list accessed by your queries. If you see dozens of columns being read for simple logic, select star is likely hiding in the code and should be eliminated.
Scenario 15. Implicit sorting assumptions. When reports lie without dumping.
You migrate a custom inventory aging report from ECC to S/4HANA. The program activates cleanly and produces output. During reconciliation, business users notice that stock quantities and values do not match standard reports. Some materials look correct, others are subtly wrong. There are no dumps, no errors, and no obvious pattern, just silent mistrust in the numbers.
The real reason for failure.
This failure is caused by relying on an execution order that no longer exists. 1. In ECC, Databases often returned records in primary key order even without an explicit order by clause. 2. Developers unknowingly relied on this behavior when looping, grouping, or using binary search. 3. SAP HANA executes queries in parallel and returns results in a non-deterministic order. 4. Any ABAP logic that assumes implicit sorting can silently produce incorrect results on S/4HANA. Here is ABAP code showing how implicit sorting assumptions break inventory aggregation logic on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the code where the assumption begins. This select statement does not specify any order by clause. In ECC, the database often returned records grouped by M, a T, and R by coincidence. This code snippet shows control break logic that assumes all movements for a material arrive together. On SAP HANA, this assumption is invalid because result ordering is not guaranteed. Here is where the damage becomes visible. Totals are printed based on incorrect grouping. The program finishes successfully, but the business result is wrong.
The fix, the interview-winning answer.
The correct fix is about enforcing determinism in application logic. First, assume that database result order is undefined unless explicitly enforced. Second, identify all places where grouping, control break logic, or binary search is used. Third, explicitly sort internal tables before any logic that depends on record order. Fourth, decide whether sorting belongs in the database or the application layer based on volume and reuse. Finally, document sorting as a functional requirement so it is not removed during optimization. This answer demonstrates deep understanding of execution models and data correctness. Here is ABAP code showing how explicit sorting restores correct inventory aggregation on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the critical fix. This line of code enforces deterministic ordering so that all movements for a material are processed together. This code snippet now behaves correctly because the internal table order matches the grouping logic used in the loop. Here is the same output logic as before, but now totals are stable, repeatable, and correct across all environments.
Follow-up 1. Why is this problem harder to detect than a dump?
Answer: because the program completes successfully and produces output that looks reasonable. There is no technical failure signal. The error only appears during reconciliation or business validation, which makes it far more dangerous than a runtime dump.
Follow-up 2. Should we always use order by instead of sort?
Answer: not necessarily. Order by shifts the cost to the database and can impact CPU under high volume. Sort in ABAP is often cheaper when ordering is only needed locally. The decision depends on data volume, reuse, and execution frequency.
Follow-up 3. Curveball. Why does this issue often appear only after go-live?
Answer: production systems trigger parallel execution due to larger datasets. Parallelism increases non-deterministic ordering. In dev or QA, smaller datasets may coincidentally appear ordered, masking the issue until real business volume is applied.
Exclusive pro tip: ATC control break checks.
Enable ATC checks for control break logic without explicit sorting. These checks can proactively identify loops that depend on implicit ordering before they cause silent production issues.
Scenario 16. For all entries, the empty table catastrophe.
You migrate a custom sales and billing reconciliation report from ECC to S/4HANA. During testing, the report works perfectly. After go live, it suddenly runs for hours and locks the system. The database shows massive full table scans on VBAP and VBRP. The code has not changed. The data volume has.
The real reason for failure.
This failure is caused by a misunderstood open SQL contract that becomes lethal at scale. 1. For all entries behaves like an enlist only if the driving internal table is not empty. 2. If the internal table is empty, the where condition is ignored entirely. 3. This results in a full table scan on the target table without warning or error. 4. On SAP HANA, full table scans scale catastrophically due to parallel execution. Here is ABAP code showing how for all entries causes a catastrophic full table scan on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the driving select. This code assumes that at least one sales order will always be selected. That assumption is often false in production edge cases. This line of code is the danger zone. If LT_VBAC is empty, SAP ignores the where condition entirely and selects all records from VBAP. Here is where the catastrophe occurs. Instead of selecting a small subset, the database performs a full table scan on VBAP, potentially fetching millions of rows.
The fix, the interview-winning answer.
The fix is about defensive programming and respecting open SQL contracts. First, never execute a for all entries query without checking that the driving internal table is not empty. Second, explicitly guard the select with an if LT_table is not initial condition. Third, consider replacing for all entries with join or subqueries where possible. Fourth, test edge cases where selection criteria return 0 records. Finally, treat for all entries as a controlled optimization, not a default pattern. This answer demonstrates deep knowledge of open SQL behavior and production risk. Here is ABAP code showing how defensive checks prevent for all entries disasters on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the critical guard condition. This ensures the for all entries clause is only executed when the driving table contains data. This code snippet is now safe. The open SQL contract is respected, preventing accidental full table scans. Here is defensive handling for edge cases. Instead of overloading the database, the program exits gracefully.
Follow-up 1. Why didn't this issue appear in ECC?
Answer: ECC systems typically had smaller data volumes and less parallel execution. Even when a full table scan occurred, the performance impact was often tolerable. SAP HANA magnifies this mistake due to in-memory parallel processing.
Follow-up 2. Should for all entries be avoided entirely on S4HANA?
Answer: not necessarily. For all entries can still be efficient when used correctly with proper guards. However, modern open SQL join or CDS views are often safer and more scalable alternatives.
Follow-up 3. Curveball. Why is this considered more dangerous than select star?
Answer: because it can silently turn a selective query into a full table scan without changing the code. Select star is visible in code reviews. An empty for all entries table is a runtime condition that often escapes detection until production.
Exclusive pro tip. ATC for all entries check.
Enable the ATC check for all entries without emptiness checks. This single rule has prevented more production outages than almost any other static check in S/4HANA migrations.
Scenario 17. Secondary indexes. Why your old tuning tricks stop working.
After migrating to S/4HANA, a custom report that was previously tuned using secondary indexes suddenly performs worse. Developers try adding more indexes, but performance does not improve. In some cases, the system even ignores the newly created indexes entirely.
The real reason for failure.
This failure is caused by applying row store tuning techniques to a column store database. 1. ECC databases relied heavily on secondary indexes to speed up row-based access. 2. SAP HANA is optimized for full column scans and in-memory processing. 3. HANA's optimizer often ignores secondary indexes if a column scan is cheaper. 4. Adding indexes without understanding the execution plan provides no benefit. Here is ABAP code relying on secondary index-driven access patterns. Disclaimer: always test code in a non-production environment. Here is the code assuming that a secondary index will efficiently narrow down the result set. On SAP HANA, the optimizer may choose a column scan instead. Here is ABAP code aligned with SAP HANA column store execution. Disclaimer: always test code in a non-production environment. Here is the key shift. Aggregation is pushed to the database, allowing SAP HANA to exploit in-memory column scans instead of relying on secondary indexes.
Why index-based thinking breaks on SAP HANA?
SAP HANA is designed to scan compressed columns in memory faster than navigating index trees. Optimizing for HANA means reducing data movement and pushing logic down, not adding more indexes.
The fix, the interview-winning answer.
A senior architect reframes the performance discussion entirely. 1. Stop assuming that secondary indexes are the primary tuning mechanism on SAP HANA. 2. Design queries that allow the optimizer to use column pruning and in-memory scans. 3. Push aggregations and filters into the database instead of post-processing in ABAP. 4. Use execution plans and SQL traces to validate access paths, not assumptions. 5. Treat index creation as an exception, not a default optimization strategy.
Follow-up 1. Are secondary indexes completely useless on SAP HANA?
Answer: no. Secondary indexes can still help in very specific scenarios, such as highly selective point queries. However, they are far less central to performance tuning than they were in row store databases.
Follow-up 2. How do we know whether HANA is using an index or not?
Answer: by analyzing the SQL execution plan using tools like SD05 or Plan Viz. These tools show whether the optimizer chose an index access or a column scan, removing guesswork from performance analysis.
Follow-up 3. Curveball. Why do some custom indexes actually slow systems down on HANA?
Answer: indexes consume memory and must be maintained during inserts and updates. If the optimizer does not use them, they become pure overhead, increasing memory pressure and write costs without any read benefit.
Exclusive pro tip. Trust the optimizer, then verify.
Before creating any secondary index on SAP HANA, capture an execution plan. If the optimizer prefers a column scan, an index will not help and may hurt.
Scenario 18. Select single verses up to 1 rows, the non-deterministic trap.
After migrating to S/4HANA, a custom validation program starts behaving inconsistently. Sometimes it picks the correct record. Other times it picks a different one. The code has not changed, the data looks fine, and there are no dumps. The issue appears random and is extremely hard to reproduce.
The real reason for failure.
This issue is caused by misunderstanding how record selection works without ordering. 1. Select single does not mean first record. It means any one matching record. 2. Without order by, SAP HANA may return different records across executions. 3. Parallel execution on HANA increases non-deterministic selection. 4. Code that assumes consistent record selection becomes unreliable. Here is ABAP code using select single without deterministic ordering. Disclaimer: always test code in a non-production environment. Here is the code that causes the issue. Select single returns an arbitrary matching row when no order by clause is specified, which leads to inconsistent behavior. Here is ABAP code enforcing deterministic record selection on SAP HANA. Disclaimer: always test code in a non-production environment. This code snippet enforces deterministic selection by explicitly defining which record should be treated as first. The behavior is now stable across executions.
Why non-deterministic selection is dangerous.
Non-deterministic behavior is one of the hardest problems to debug in distributed systems. On SAP HANA, parallel execution can expose assumptions that previously went unnoticed in ECC systems.
The fix, the interview-winning answer.
A senior architect explains this as a determinism problem, not a syntax issue. 1. Never assume select single returns a consistent record unless ordering is enforced. 2. Use order by with up to 1 rows when record choice matters. 3. Design logic so that selection criteria uniquely identify a record whenever possible. 4. Treat non-determinism as a production risk, not a cosmetic bug.
Follow-up 1. Why didn't this issue show up in ECC?
Answer: ECC databases often returned records in a stable physical order due to row-based storage. Developers unknowingly relied on this behavior. SAP HANA removes that guarantee through parallel execution.
Follow-up 2. Is select single completely unsafe on SAP HANA?
Answer: no. Select single is safe when the where clause uniquely identifies one record, such as by primary key. The danger appears only when multiple rows can match the condition.
Follow-up 3. Curveball. Why can this cause intermittent production bugs?
Answer: because execution order can change based on system load, data distribution, and parallelism. The same code may behave differently across runs, creating hard-to-reproduce issues that only appear under real workload.
Exclusive pro tip. ATC non-deterministic select checks.
Enable ATC checks that flag select single statements without unique key conditions. These checks catch non-deterministic logic early, before it turns into a production mystery.
Scenario 19. Code pushdown failure. When ABAP loops kill HANA performance.
You migrate a profitability analysis report from ECC to S/4HANA. The report aggregates revenue and cost by customer and fiscal year. It works correctly, but runtime increases exponentially as data volume grows. During month-end, the report becomes unusable, despite running on an in-memory database.
The real reason for failure.
Failure occurs because the application ignores the strengths of SAP HANA. 1. ECC-era ABAP logic often pulled large datasets into the application server for processing. 2. SAP HANA is optimized for executing aggregations directly in the database layer. 3. ABAP loops force row-by-row processing, defeating parallel in-memory execution. 4. Excessive data transfer between database and application server becomes the bottleneck. Here is ABAP code showing how loop-based aggregation defeats SAP HANA performance. Disclaimer: always test code in a non-production environment. Here is the code pulling all billing line items into the ABAP layer. This forces SAP HANA to transfer large volumes of data out of the database. This code snippet shows row-by-row processing in ABAP. This pattern completely bypasses HANA's ability to process data in parallel. Here is the business logic itself. The calculation is simple, but it is executed millions of times in the application layer instead of once in the database.
The fix, the interview-winning answer.
The correct fix is to redesign the logic around database execution. First, identify aggregation logic that can be executed at the database level. Second, replace ABAP loops with open SQL aggregations or CDS views. Third, minimize data transfer between SAP HANA and the ABAP application server. Fourth, design reports assuming large data volumes and parallel execution. Finally, treat code pushdown as a default design principle, not an optimization. This answer demonstrates a true understanding of HANA's execution model. Here is ABAP code showing how database-level aggregation restores scalability on SAP HANA. Disclaimer: always test code in a non-production environment. Here is the core pushdown change. Aggregation is executed entirely inside SAP HANA, leveraging in-memory parallel processing. This code snippet shows that only the final aggregated value is transferred to the application server. Here is the unchanged output logic. Business results remain correct, while performance improves dramatically.
Follow-up 1. Why did loop-based logic work fine in ECC?
Answer: ECC databases were optimized for transactional workloads, and application servers handled much of the processing. Data volumes were smaller, and parallel execution was limited, masking inefficiencies that SAP HANA exposes immediately.
Follow-up 2. Should all logic be pushed down to the database?
Answer: no. Only data-intensive, set-based operations should be pushed down. Complex business rules, validations, and orchestration logic often still belong in ABAP. The architect's role is to choose the correct execution layer.
Follow-up 3. Curveball. Why can partial pushdown be worse than no pushdown?
Answer: because splitting logic across layers can increase data transfer and complexity. If not designed carefully, partial pushdown creates chatty interfaces between ABAP and the database, negating HANA's advantages.
Exclusive pro tip. Use SD05 to find pushdown candidates.
Run SD05 SQL trace and look for large result sets followed by ABAP loops. These are prime candidates for code pushdown and often deliver the biggest performance gains.
Section 3 complete. HANA does exactly what you ask, not what you assume.
Section 3 exposed the most dangerous class of migration failures: silent correctness issues and performance collapses caused by invalid assumptions about database behavior. SAP HANA is not forgiving. It executes exactly what the code specifies, not what legacy systems happen to return by coincidence. At this point, teams often believe the hard part is over. In reality, the next failures are even more brutal because the tables themselves start disappearing.
The next shock, your tables are gone.
In S/4HANA, SAP did not just optimize the database. It redesigned the data model. Tables you queried directly for decades are removed, replaced, or hidden behind compatibility layers.
Section 4. The vanishing tables, data model redesign.
This section focuses on data model changes that break compilation, invalidate joins, and destroy long-standing reporting logic. These failures are immediate, visible, and often block go-live if not addressed correctly. Understanding which tables are physically removed, which are replaced, and which are exposed only via views is a core skill for any S/4HANA technical architect.
Scenarios covered in this category.
20. Direct table access and proxy objects. 21. MATDOC inventory data model redesign. 22. VBox table removal rebates. 23. BSEG versus ACDOCA. 24. KONV to PRCD elements. 25. Field length extensions, MATNR, etc. These issues fail fast either at syntax check or during first execution.
Scenario 20. Direct table access, when SAP blocks you on purpose.
After migrating to S/4HANA, a custom report that directly reads a standard SAP table suddenly fails syntax checks. The table still exists in the system, but activation is blocked with warnings or errors. Developers are confused because the data is clearly visible in SE16N.
The real reason for failure.
This failure is intentional and enforced by SAP. 1. SAP has introduced strict encapsulation rules for many application tables. 2. Direct access to certain tables is blocked to protect business consistency. 3. These tables are meant to be accessed only via APIs, CDS views, or classes. 4. S/4HANA enforces this at syntax and runtime level to prevent data corruption. Here is a ABAP code, attempting direct access to a restricted application table. Disclaimer: always test code in a non-production environment. Here is the code triggering the issue. Although the table exists, SAP flags this access because but000 is protected and not intended for direct use in custom code. Here is a ABAP code accessing the same data, using a released CDS view. Disclaimer: always test code in a non-production environment. This code snippet uses a released CDS view. SAP guarantees its stability across upgrades and allows controlled access to business partner data.
Why SAP enforces proxy objects.
Direct table access tightly couples custom code to SAP's internal data model. Proxy objects such as CDS views and APIs decouple extensions from physical tables, allowing SAP to evolve the core without breaking customers.
The fix, the interview-winning answer.
A senior architect explains this as an extensibility and upgrade safety issue. 1. Never rely on direct access to SAP application tables in S/4HANA. 2. Use released CDS views or APIs as the primary access mechanism. 3. Treat syntax warnings as design guidance, not obstacles to bypass. 4. Design custom code to survive SAP upgrades, not just compile today.
Follow-up 1. If the table exists, why does SAP block access?
Answer: because the table is an internal implementation detail. SAP reserves the right to change or remove it. Blocking access protects both SAP and customers from fragile custom developments.
Follow-up 2. Can we suppress the warning and continue?
Answer: technically yes in some cases, but it is strongly discouraged. Suppressing the warning creates technical debt and risks breaking the code in future support packages or upgrades.
Follow-up 3. Curveball. What if no CDS view exists for the data we need?
Answer: then you must either request a released API from SAP, build your own CDS view on top of released views, or redesign the requirement. Direct table access should be the absolute last resort.
Exclusive pro tip. Check the API state in ADT.
In Eclipse ADT, always check the API state of tables, views, and classes. If it is not marked as released, assume it can break in the next upgrade.
Scenario 21. MATDOC. When inventory logic implodes after migration.
You migrate a custom inventory movement and stock valuation report from ECC to S/4HANA. The program compiles after minor fixes, but functional testing reveals mismatched quantities and duplicate postings. In some cases, stock appears doubled. The joins look correct, yet the numbers do not reconcile with standard reports like MB52 or MMBE.
The real reason for failure.
This failure is caused by a fundamental redesign of the inventory data model. 1. In ECC, inventory data was split across MKPF header and MSEG item tables. 2. custom reports frequently joined MKPF and MSEG directly to derive stock movements. 3. In S/4HANA, SAP introduced MATDOC as a single source of truth for inventory postings. 4. Joining legacy tables, or mixing MATDOC with MSEG, leads to duplicate or inconsistent results. Here is a BAP code showing legacy, MKPF MSEG, joins that break inventory correctness on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the legacy header selection. In ECC, MKPF represented the authoritative header for material documents. This code snippet joins MSEG to MKPF. On S/4HANA, this logic is no longer valid because inventory postings are consolidated into MATDOC. Here is where the totals are calculated. Because data is duplicated or partially overlapping, quantities are inflated or inconsistent.
The fix, the interview-winning answer.
The correct fix is to realign custom code with the new inventory architecture. First, stop using MKPF and MSEG as the primary source for inventory reporting in S/4HANA. Second, treat MATDOC as the single source of truth for material document data. Third, redesign joins and aggregations to use MATDOC or released CDS views built on it. Fourth, validate results against standard S/4HANA inventory reports to ensure semantic alignment. Finally, document the data model change to prevent regression during future enhancements. This answer demonstrates architectural awareness, not just technical remediation. Here is a BAP code showing how MATDOC restores correct inventory aggregation on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the architectural shift. MATDOC consolidates header and item information into a single, consistent structure. This code snippet shows filtering directly on MATDOC, eliminating the need for complex joins. Here is the same aggregation logic as before, but now operating on a clean, non-duplicated dataset.
Follow-up 1. Can we still use MKPF and MSEG in S/4HANA?
Answer: they still exist for compatibility and specific technical purposes, but they are no longer the authoritative source for inventory reporting. SAP explicitly recommends using MATDOC or CDS views built on it.
Follow-up 2. Why does SAP keep MKPF and MSEG if MATDOC exists?
Answer: for backward compatibility and technical processing. Removing them outright would break too much legacy code. However, relying on them for new development introduces correctness and upgrade risks.
Follow-up 3. Curveball. Why do some MATDOC queries return more records than MSEG?
Answer: because MATDOC stores inventory at a more granular level, including additional dimensions such as stock type and valuation. Reports must be adapted semantically, not just technically.
Exclusive pro tip. Prefer CDS views over direct MATDOC access.
Whenever possible, use SAP-delivered CDS views on top of MATDOC. They encapsulate business semantics and protect your code from future data model changes.
Scenario 22. VBox table removal. When rebate logic silently breaks.
You migrate a custom rebate accrual and settlement report from ECC to S/4HANA. The program activates after adjustments, but reconciliation with finance reveals missing or duplicated rebate values. Standard rebate reports no longer match the custom output, even though the selection logic appears unchanged.
The real reason for failure.
This failure is caused by the complete removal of rebate index tables. 1. In ECC, VBox tables acted as performance-optimized index tables for rebate processing. 2. Custom code often read VBox tables directly to calculate accruals and settlements. 3. In S/4HANA, SAP removed VBox tables entirely as part of data model simplification. 4. Any logic relying on VBox tables either fails at activation or produces incomplete results. Here is a BAP code showing direct VBox table access, used for rebate calculation in ECC. Disclaimer: always test code in a non-production environment. Here is the legacy access pattern. This select statement worked in ECC because VBox physically existed as a rebate index table. This code snippet calculates rebate totals based on index entries. In S/4HANA, this dataset no longer exists. Here is the business logic. The calculation itself is correct, but the data source is invalid after migration.
The fix, the interview-winning answer.
The correct fix is to redesign rebate logic around the new pricing architecture. First, stop reading VBox tables entirely. They no longer exist in S/4HANA. Second, identify whether rebate logic belongs to pricing conditions or financial postings. Third, fetch rebate data from PRCD elements or accounting tables such as ACDOCA, depending on the business requirement. Fourth, use released APIs or CDS views instead of reconstructing rebate logic manually. Finally, reconcile custom outputs with standard S/4HANA rebate and pricing reports. This answer shows an understanding of both SD pricing and finance integration. Here is a BAP code showing rebate calculation using pricing condition data on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the correct S/4HANA data source. PRCD elements replaces multiple legacy pricing and rebate tables. This code snippet filters rebate-specific pricing conditions. The logic is now aligned with pricing determination. Here is the aggregation logic executed on valid data. The calculation is now consistent with standard pricing behavior.
Follow-up 1. Why did SAP remove VBox tables instead of keeping them as compatibility objects?
Answer: VBox tables duplicated data already available in pricing and accounting structures. On SAP HANA, such redundancy is unnecessary and costly. SAP chose correctness and simplicity over backward convenience.
Follow-up 2. Should rebate reporting be done from pricing or finance?
Answer: it depends on the business question. Pricing data reflects calculated conditions, while finance reflects posted accruals and settlements. A senior architect clarifies this distinction before designing the report.
Follow-up 3. Curveball. Why do rebate values sometimes differ between SD and FI in S/4HANA?
Answer: because timing, accrual logic, and settlement postings differ. SD pricing shows condition values, while FI reflects actual postings. Misunderstanding this leads to false reconciliation issues.
Exclusive pro tip. Always ask where is the truth.
Before rebuilding rebate logic, clarify whether the business wants pricing conditions, accrued values, or posted financial amounts. The answer determines the correct data source.
Scenario 23. BSEG versus ACDOCA. When finance reports lie after migration.
You migrate a custom financial line item report from ECC to S/4HANA. The report compiles and runs, but finance users report that balances do not match standard reports like FBL3N or FAGLL03. Some postings appear duplicated, while others seem to be missing entirely.
The real reason for failure.
This failure is caused by a fundamental redesign of the financial data model. 1. In ECC, BSEG was the primary table for line item level financial reporting. 2. Custom reports often joined BKPF and BSEG directly to calculate balances. 3. In S/4HANA, SAP introduced ACDOCA as the universal journal, consolidating multiple FI tables. 4. Mixing BSEG with ACDOCA, or relying solely on BSEG, leads to incorrect financial results. Here is a BAP code showing legacy BKPFB SEG joins that produce incorrect balances on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the header selection logic from ECC-style reports. In S/4HANA, BKPF no longer represents the full financial truth. This code snippet pulls line items from BSEG. On S/4HANA, BSEG is no longer the authoritative source for financial reporting. Here is the aggregation logic. Because BSEG no longer contains the complete picture, the calculated balance becomes unreliable.
The fix, the interview-winning answer.
The correct fix is to realign custom financial reporting with the universal journal. First, stop using BSEG as the primary reporting table in S/4HANA. Second, treat ACDOCA as the single source of truth for all financial line items. Third, redesign custom reports to query ACDOCA directly or via released CDS views. Fourth, Validate balances against standard S/4HANA financial reports. Finally, ensure currency and ledger dimensions are handled correctly in the new model. This answer shows deep understanding of S/4HANA finance architecture. Here is a BAP code showing correct financial aggregation using ACDOCA on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the architectural correction. ACDOCA contains all financial postings across FI, CO, A, and ML. This code snippet shows account-based filtering, aligned with the universal journal structure. Here is the aggregation logic, using the correct amount field in the universal journal.
Follow-up 1. Can we still use BSEG for any reporting in S/4HANA?
Answer: BSEG still exists for compatibility, but it is not complete and should not be used for new reporting. SAP explicitly recommends ACDOCA or CDS views built on it for financial analytics.
Follow-up 2. Why do balances differ between BSEG and ACDOCA?
Answer: because ACDOCA contains additional postings and dimensions that never existed in BSEG. Using BSEG after migration ignores parts of the financial truth.
Follow-up 3. Curveball. Why do some ACDOCA queries return more rows than expected?
Answer: because ACDOCA stores line items at a higher granularity, including multiple ledgers and currencies. Reports must explicitly filter by ledger and currency type.
Exclusive pro tip: always filter by ledger.
When querying ACDOCA, always filter by ledger, RLDNR. Failing to do so is one of the most common causes of duplicated balances in custom reports.
Scenario 24. KONV to PRCD elements. When pricing logic stops compiling.
You migrate a custom sales pricing analysis report from ECC to S/4HANA. During activation, the program fails with a syntax error stating that table KONV does not exist. This blocks the entire transport. The business insists the report is critical for revenue reconciliation.
The real reason for failure.
This failure is caused by a deliberate pricing data model redesign. 1. In ECC, KONV was a cluster table storing pricing condition values. 2. Custom reports frequently queried KONV directly for pricing analysis. 3. S/4HANA removed KONV completely as part of data model simplification. 4. Pricing data is now stored in the transparent table PRCD elements. Here is a BAP code showing direct KONV access that fails to activate on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the exact point of failure. KONV no longer exists physically in S/4HANA, so this code cannot even be activated. This code snippet shows pricing aggregation logic that depends entirely on a removed data source. Here is the pricing amount field that has changed semantics and structure in S/4HANA.
The fix: the interview-winning answer.
The correct fix requires both technical and functional understanding of pricing. First, replace all direct KONV access with PRCD elements. Second, adjust internal table definitions to match the new key and field structure. Third, identify pricing conditions explicitly instead of assuming KONV behavior. Fourth, validate pricing totals against standard S/4HANA pricing reports. Finally, prefer released pricing APIs or CDS views to future-proof the solution. This answer shows mastery of SD pricing changes in S/4HANA. Here is a BAP code showing correct pricing aggregation using PRCD elements on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the correct S/4HANA pricing table. PRCD elements consolidates all pricing condition data. This code snippet shows explicit condition filtering. In S/4HANA, pricing logic must be precise and intentional. Here is the same aggregation logic, now operating on the correct and supported pricing structure.
Follow-up 1. Why did SAP remove KONV instead of keeping it as a view?
Answer: KONV was a cluster table optimized for legacy databases. On SAP HANA, cluster tables are inefficient and unnecessary. SAP chose a clean redesign rather than preserving outdated structures.
Follow-up 2. Can we use compatibility views like VKONV?
Answer: compatibility views exist but are read-only and significantly slower. SAP recommends them only for temporary remediation, not for long-term custom development.
Follow-up 3, Curveball. Why do pricing values sometimes differ after migration?
Answer: because condition evaluation, rounding, and accrual timing may differ between ECC and S/4HANA. Pricing logic must be validated functionally, not just technically.
Exclusive pro tip. Always revalidate pricing with SD.
Never assume pricing logic migrated correctly just because the code compiles. Always reconcile with SD consultants and standard pricing reports.
Scenario 25, Field Length Extensions. When MATDOC suddenly truncates data.
After migrating to S/4HANA, a custom interface and several reports start behaving strangely. Material numbers appear truncated, selection screens reject valid inputs, and comparisons fail even though the values look correct on the screen. No dumps occur, but business processes start breaking silently.
The real reason for failure.
This failure is caused by mandatory field length extensions in S/4HANA. 1. In ECC, material number MATNR was 18 characters long. 2. In S/4HANA, MATNR was extended to 40 characters to support future business scenarios. 3. Custom code using hard-coded char 18 or legacy domains silently truncates values. 4. String comparisons and selections fail without throwing syntax or runtime errors. Here is a BAP code using legacy char 18 declarations for material numbers. Disclaimer: always test code in a non-production environment. Here is the root of the problem. This variable can only hold 18 characters, causing silent truncation when longer material numbers are used. Here is a BAP code using the MATNR data element for S/4HANA compatibility. Disclaimer: always test code in a non-production environment. This code snippet uses the MATNR data element, which automatically adapts to the correct field length in S/4HANA.
Why field length extensions are dangerous.
Field length extensions break assumptions embedded deep inside custom code. Because they do not always cause dumps, they create silent data corruption and comparison failures that are difficult to trace.
The fix, the interview-winning answer.
A senior architect frames this as a design discipline issue. 1. Never hardcode field lengths for business objects in custom code. 2. Always use SAP-delivered data elements and domains. 3. Treat field length extensions as functional changes, not technical ones. 4. Run ATC checks specifically for field length compatibility before go live.
Follow-up 1. Why don't these issues cause syntax errors?
Answer: because char-based declarations are technically valid. The compiler has no way of knowing the business meaning of the field, so the problem only appears at runtime.
Follow-up 2. Which other fields are commonly extended in S/4HANA?
Answer: fields like MATNR, KUNNR, LIFNR, and BELNR are commonly impacted. SAP provides simplification notes listing all mandatory extensions.
Follow-up 3, Curveball. Why do these bugs often appear only in interfaces?
Answer: interfaces frequently exchange external identifiers and longer values. Truncation happens before the data reaches SAP logic, making the issue harder to diagnose.
Exclusive pro tip. Use DDIC where used lists.
Before migration, run where used checks on extended data elements to find hard-coded char declarations that must be fixed.
Section 4 complete. When the ground truth changes.
Section 4 exposed a hard reality of S/4HANA migrations. Many failures are not caused by bad code, but by querying data models that no longer represent business truth. Tables did not just change names. Their meaning, granularity, and ownership fundamentally shifted. Teams that try to preserve legacy joins and shortcuts at this stage usually succeed only in compiling broken logic. The cost is paid later, during reconciliation, audits, and go-live escalations.
Now comes the hardest pill to swallow.
So far, we have dealt with disappearing tables and redesigned structures. But none of those changes compare to what happens when finance itself is re-architected. In S/4HANA, SAP did not optimize finance. SAP replaced it.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S/4HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Section 5, Universal Journal Finance Without Silos.
The Universal Journal is not just a table called ACDOCA. It is a complete redesign of how financial truth is stored, reconciled, and reported. FICO, asset accounting, and material ledger no longer live in separate worlds. This section focuses on finance-specific failure modes that break balances, confuse auditors, and instantly expose whether a technical architect truly understands S/4HANA or is just fixing syntax.
Scenarios covered in this category.
26. Architecture of a CDOCA Universal Journal. 27. GLFLEX and a new GL migration impact. 28. Compatibility views in finance VBSEG VCOEP. 29. Currency fields and ledger dimensions. 30. Reporting with header and item in one shot. These scenarios determine whether finance trusts your system after go live.
Scenario 26, the Universal Journal, when finance stops reconciling.
After migrating to S/4HANA, finance teams notice something unsettling. Traditional reconciliation activities between FICO, asset accounting, and material ledger no longer behave the way they used to. Some reconciliation steps disappear entirely, while others appear redundant. Auditors start asking uncomfortable questions.
The real reason for failure.
This is not a reporting issue. It is a paradigm shift in financial architecture. 1. In ECC, FICO, asset accounting, and material ledger stored data in separate tables. 2. Reconciliation was required because financial truth was distributed across multiple ledgers. 3. In S/4HANA, SAP introduced ACDOCA as a single line item table for all finance components. 4. Many traditional reconciliation steps become obsolete or meaningless.
Why this breaks finance projects.
Teams that treat ACDOCA as just another table miss the point entirely. The Universal Journal eliminates entire classes of reconciliation logic. If users are not educated, they will assume data is missing when, in reality, processes have fundamentally changed.
The fix, the interview-winning answer.
A senior architect explains this as a finance transformation, not a technical upgrade. 1. Educate finance users that FI and CO are no longer reconciled. They are unified. 2. Redesign reports and controls to consume ACDOCA directly or via CDS views. 3. Retire reconciliation programs that compare FI and CO balances. 4. Align audit procedures with the Universal Journal concept. 5. Treat ACDOCA as the single source of financial truth.
Follow-up 1. Why do auditors initially distrust ACDOCA?
Answer: because traditional audit procedures are built around reconciliation. When reconciliation disappears, it feels like a control gap. The reality is that the control moved into the data model itself.
Follow-up 2. Does this mean FI and CO are fully merged?
Answer: conceptually yes, but configuration and reporting perspectives still exist. The key difference is that postings are written once and reused, instead of duplicated across modules.
Follow-up 3. Curveball. Why do some companies still run reconciliation reports in S/4HANA?
Answer: because legacy processes were copied forward without redesign. These reports often reconcile a system with itself, creating false alarms and unnecessary operational noise.
Exclusive pro tip. Reconciliation is a smell.
In S/4HANA, heavy reconciliation logic usually indicates that the system is not being used as designed. Investigate the architecture before fixing the numbers.
Scenario 27. FAGLFLEX a migration impact when new GL logic breaks.
After migrating from ECC new GL to S/4HANA, custom financial reports that previously read FAGLFLEX suddenly stop working or return incomplete balances. Developers notice that the table still exists, but values no longer reconcile with standard S/4HANA financial reports.
The real reason for failure.
This failure is caused by the retirement of new GL totals tables. 1. In ECC, FAGLFLEX stored aggregated general ledger totals. 2. Custom reports often relied on FAGLFLEX for fast balance reporting. 3. In S/4HANA, totals tables are eliminated in favor of real-time aggregation. 4. ACDOCA replaces both line item and totals-based reporting. Here is a ABAP code reading FAGLFLEX, totals that no longer represent financial truth. Disclaimer: always test code in a non-production environment. Here is the legacy access pattern. FAGLFLEX still exists, but it is no longer updated or complete in S/4HANA. Here is a ABAP code deriving balances directly from ACDOCA on S/4HANA. Disclaimer: always test code in a non-production environment. This code snippet shows the correct approach. Totals are derived dynamically from line items in the Universal Journal.
Why totals tables no longer exist?
Totals tables were necessary in ECC because aggregation at runtime was expensive. SAP HANA eliminates that need by aggregating millions of line items in memory with negligible delay.
The fix, the interview-winning answer.
A senior architect frames this as a design evolution, not a regression. 1. Stop using totals tables like FAGLFLEX in S/4HANA. 2. Derive balances dynamically from ACDOCA. 3. Accept that reporting is now real-time, not pre-aggregated. 4. Validate performance using HANA execution plans, not legacy assumptions.
Follow-up 1. Why does FAGLFLEX still exist if it's obsolete?
Answer: for technical compatibility during migration. SAP keeps it to avoid breaking all legacy code immediately, but it is not meant for active reporting.
Follow-up 2. Won't dynamic aggregation be slower than totals tables?
Answer: on traditional databases, yes. On SAP HANA, columnar in-memory processing makes real-time aggregation faster and more flexible than pre-stored totals.
Follow-up 3. Curveball. Why do some migrated systems still show correct values in FAGLFLEXA?
Answer: because historical data may still exist, but new postings are no longer reflected correctly. This creates a dangerous illusion of correctness.
Exclusive pro tip. Totals tables are a red flag.
If a custom S/4HANA report reads a totals table, assume it is architecturally wrong until proven otherwise.
Scenario 28. Compatibility views. When your report is technically correct but architecturally wrong.
After fixing syntax errors during S/4HANA migration, a custom finance report compiles and runs successfully using views like VBSEG or VCOEP. At first glance, the output looks correct. However, performance is poor, and SAP reviewers flag the code as non-compliant during quality checks.
The real reason for failure.
This issue is caused by misunderstanding the purpose of compatibility views. 1. Compatibility views exist to prevent immediate failures during migration. 2. They translate legacy table structures into the new S/4HANA data model. 3. They are not optimized for performance or long-term use. 4. SAP explicitly discourages their use in custom developments. Here is a BAP code using a compatibility view for financial reporting. Disclaimer: always test code in a non-production environment. Here is the compatibility shortcut. Although this works, the view translates data at runtime, which adds overhead and hides the real data model. Here is a BAP code using ACDOC instead of a compatibility view. Disclaimer: always test code in a non-production environment. This code snippet accesses the Universal Journal directly. It is faster, clearer, and aligned with SAP's recommended architecture.
Why compatibility views are a migration trap?
Compatibility views are meant to buy time during conversion, not to serve as a foundation for new development. Using them long-term creates technical debt and performance risks.
The fix, the interview-winning answer.
A senior architect explains this as a temporary crutch, not a solution. 1. Use compatibility views only to stabilize the system during migration. 2. Refactor custom reports to consume ACDOC or released CDS views. 3. Avoid building new logic on top of compatibility layers. 4. Treat any use of V_views as technical debt.
Follow-up 1. Why does SAP allow compatibility views at all?
Answer: because immediate removal would break most customer systems. They allow phased migration while teams refactor code properly.
Follow-up 2. Are compatibility views guaranteed to exist forever?
Answer: no. SAP makes no long-term guarantees. Future releases may restrict or remove them, making dependency risky.
Follow-up 3. Curveball. Why do compatibility views often perform worse over time?
Answer: as data volume grows, runtime translations become more expensive. What works in early testing often collapses under production load.
Exclusive pro tip. Search for V_usage.
During code remediation, globally search for V_views. Each occurrence should trigger a redesign discussion.
Scenario 29. Currency types and ledgers, when balances look right but are still wrong.
After migrating to S/4HANA, finance users run a custom balance report and immediately raise concerns. The totals appear correct in one currency, incorrect in another, and inconsistent when compared across reports. The data exists, but nobody can agree on which number is the real one.
The real reason for failure.
This issue is caused by misunderstanding how S/4HANA stores financial amounts. 1. In ECC, different currency types were stored in separate tables or derived implicitly. 2. In S/4HANA, multiple currency types are stored side by side in ACDOCA. 3. Each amount field represents a different semantic meaning, not just a conversion. 4. Failing to choose the correct currency type leads to logically incorrect reporting.
Why this breaks finance trust?
Finance users expect a single authoritative number. When reports show multiple values without clear explanation, confidence in the system erodes quickly, even if the data is technically correct.
The fix, the interview-winning answer.
A senior architect explains this as a semantic design problem. 1. Explicitly define which currency type the report represents. 2. Use the correct amount field based on the business requirement. 3. Align ledger and currency selection with standard S/4HANA reports. 4. Educate users that different currencies answer different questions. 5. Document currency semantics as part of the report design.
Follow-up 1. What are the most commonly used currency types in S/4HANA?
Answer: company code currency, group currency, and transaction currency are the most common. Each serves a distinct purpose and must not be mixed casually in reporting.
Follow-up 2. Why did ECC reports not face this problem as often?
Answer: because ECC often stored or derived a single dominant currency per report. S/4HANA makes all currencies available simultaneously, increasing flexibility but also responsibility.
Follow-up 3. Curveball. Why do auditors often focus on currency selection first?
Answer: because incorrect currency usage can make correct postings look wrong. Auditors know that currency semantics are a common source of misinterpretation in Universal Journal reports.
Exclusive pro tip. Mirror standard reports first.
Before finalizing a custom report, mirror the currency and ledger logic of a standard S/4HANA report. If the numbers match, you are using the data correctly.
Scenario 30. One-shot finance reporting. When header item joins become anti-patterns.
You migrate a complex financial reporting program from ECC to S/4HANA. In ECC, the report joined BKPF, BSEG, COEP, and other tables to derive balances and cost information. After migration, the report technically works but performs poorly, returns duplicated records, and produces inconsistent results when filters change.
The real reason for failure.
This failure is caused by applying document-based thinking to a line-item-centric architecture. 1. ECC reporting relied on joining header and item tables to reconstruct financial truth. 2. Multiple joins were required because data was distributed across FI, CO, and ML tables. 3. In S/4HANA, ACDOCA already contains all dimensions at line item level. 4. Rebuilding header item joins on top of a CDOCA reintroduces duplication and inefficiency. Here is a BAP code showing ECC-style header item joins that collapse on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the legacy entry point. This code assumes BKPF is required to identify financial documents, which is no longer true in S/4HANA. This code snippet pulls FI line items separately, recreating joins that already exist implicitly in the Universal Journal. Here is the CO data fetch. In S/4HANA, CO postings are already embedded in ACDOCA, making this select redundant.
The fix, the interview-winning answer.
The correct fix is to embrace one-shot reporting using the Universal Journal. First, stop reconstructing documents using BKPF, BSEG, and COEP. Second, treat ACDOCA as the complete financial fact table. Third, design reports as single-pass set-based queries. Fourth, remove redundant joins that reintroduce duplication. Finally, validate performance and correctness against standard S/4HANA reports. This answer demonstrates mastery of S/4HANA finance reporting philosophy. Here is a BAP code showing one-shot financial reporting using ACDOCA on S/4HANA. Disclaimer: always test code in a non-production environment. Here is the architectural shift. ACDOCA already contains all FI and CO dimensions, eliminating the need for joins. This code snippet shows aggregation executed directly in the database, enabling parallel processing and optimal performance. Here is the unchanged output. Business logic remains intact, while complexity and runtime are drastically reduced.
Follow-up 1. Why do developers instinctively rebuild header item joins?
Answer: because ECC trained developers to think in documents rather than line items. S/4HANA requires unlearning that habit and trusting the Universal Journal.
Follow-up 2. Can one-shot reporting replace all finance reports?
Answer: for analytical and balance reports, yes. Transactional or document navigation scenarios may still require document context, but not for aggregation.
Follow-up 3. Curveball. Why does removing joins sometimes change totals?
Answer: because legacy joins often introduce duplication unintentionally. One-shot reporting exposes the correct numbers, even if they differ from historical custom reports.
Exclusive pro tip. Count rows before you sum.
Before aggregating, count the number of line items returned. Unexpected row counts usually indicate a design flaw, not a data problem.
Section 5 complete. Finance is no longer modular.
Section 5 exposed the most radical change in S/4HANA. Finance is no longer split across independent modules and tables. The Universal Journal collapses decades of separation into a single financial truth. Projects fail here not because of missing fields or wrong syntax, but because teams continue to think in ECC-era boundaries. In S/4HANA, finance correctness is an architectural decision.
But finance is only half the story.
Once finance is unified, the next question becomes unavoidable. Who are we actually doing business with? In S/4HANA, SAP answered this by dismantling one of the oldest assumptions in ERP, the separation of customer and vendor.
Section 6. Business partner and CVI identity over objects.
Business partner is not a new table. It is a new identity model. Customers and vendors no longer exist as primary objects. They are roles assigned to a single business partner. This section focuses on master data failures that silently corrupt transactions, break integrations, and cause reconciliation chaos after go-live.
Scenarios covered in this category.
31. Business partner roles, customer and vendor are no longer objects. 32. CVI cockpit and data synchronization. 33. Synchronization direction, BP to customer or reverse. 34. Updating business partner using APIs. 35. Querying the BUT000 table family master data. Mistakes here propagate into every module.
Scenario 31. Business partner roles, when customer and vendor disappear.
After migrating to S/4HANA, users notice that familiar transactions like XD01 and XK01 are either locked or redirected. Customer and vendor master data maintenance suddenly behaves differently, and integrations that rely on KN01 or LF01 start failing.
The real reason for failure.
This failure is caused by a fundamental identity redesign. 1. In ECC, customer and vendor were separate master data objects. 2. In S/4HANA, both are roles of a single business partner. 3. Business partner is now the leading object. 4. Customer and vendor tables are derived representations.
Why this confuses project teams.
Most teams treat business partner as a technical requirement instead of a business identity model. As a result, they migrate data successfully but misunderstand ownership, synchronization, and lifecycle control.
The fix, the interview-winning answer.
A senior architect explains this as a governance decision. 1. Treat business partner as the single source of truth. 2. Understand customer and vendor as role-specific views. 3. Align integrations and interfaces to BP, not KN01 or LF01. 4. Educate business users on role-based identity. 5. Design master data governance around BP lifecycle.
Follow-up 1. Why did SAP merge customer and vendor into business partner?
Answer: because real-world entities often act as both customers and vendors. Maintaining separate identities created duplication and reconciliation issues.
Follow-up 2. Does this mean KN01 and LF01 are obsolete?
Answer: logically yes, but technically they still exist as compatibility layers. They should not be treated as leading objects.
Follow-up 3. Curveball. Why do BP issues often surface weeks after go-live?
Answer: because synchronization errors accumulate over time. The first visible symptom is usually a failed posting or integration mismatch.
Exclusive pro tip, identity first, roles second.
If a design discussion starts with customer or vendor, you are already thinking too late. Start with business partner.
Scenario 32, CVI cockpit. When migration finishes but data is still broken.
During the S/4HANA conversion, the technical migration completes successfully. Some finishes without major errors. However, once business testing begins, users encounter blocked postings, missing business partner roles, and inconsistent customer or vendor data across transactions.
The real reason for failure.
This issue is caused by misunderstanding the role of the CVI cockpit. 1. CVI is not a one-time migration step. It is a continuous synchronization framework. 2. The CVI cockpit validates alignment between business partner and customer or vendor views. 3. Ignoring CVI errors leads to incomplete or inconsistent master data. 4. Many issues surface only after transactional usage begins.
Why projects misread CVI status?
Teams often treat a green CVI status during migration as final success. In reality, CVI must remain clean throughout testing and production. New data creation and interface loads can reintroduce inconsistencies at any time.
The fix, the interview-winning answer.
A senior architect positions CVI as part of operational governance. 1. Run the CVI cockpit repeatedly during testing, not just once. 2. Resolve all synchronization errors before go live. 3. Align business processes to create and maintain business partners correctly. 4. Monitor CVI regularly in production. 5. Treat CVI errors as blockers, not warnings.
Follow-up 1. Why do CVI issues often appear after go-live?
Answer: because new master data creation, data loads, or integrations introduce inconsistencies that were not present during migration testing.
Follow-up 2. Can CVI issues fix themselves automatically?
Answer: no. CVI does not autocorrect structural inconsistencies. Each error must be analyzed and resolved explicitly.
Follow-up 3, curveball. Why do some teams disable CVI checks temporarily?
Answer: under go-live pressure, teams sometimes bypass CVI to unblock transactions. This creates long-term data corruption that is far harder to fix later.
Exclusive pro tip. CVI is a smoke detector.
If CVI reports an error, something upstream is broken. Fix the process, not just the symptom.
Scenario 33, synchronization direction. When BP and customer drift apart.
After go-live, business users report strange inconsistencies. A customer address is updated in one transaction, but the change does not appear in another. Some interfaces read outdated data, while others show the latest version. No errors are raised, but trust in master data collapses.
The real reason for failure.
This issue is caused by incorrect synchronization direction configuration. 1. In S/4HANA, business partner is the leading object by design. 2. Customer and vendor records are synchronized views of BP data. 3. If synchronization direction is misconfigured, updates flow inconsistently. 4. Some changes overwrite others depending on the entry point.
Why this is so dangerous?
Synchronization issues rarely cause immediate dumps or errors. Instead, they slowly corrupt master data across modules, integrations, and reports. By the time the issue is visible, root cause analysis becomes extremely difficult.
The fix, the interview-winning answer.
A senior architect treats synchronization direction as a governance decision. 1. Decide explicitly which object is the system of record. 2. Configure synchronization to flow from business partner outward. 3. Avoid bidirectional updates unless absolutely required. 4. Align business processes to update data through the leading object. 5. Test synchronization behavior with real transactional scenarios.
Follow-up 1. Can synchronization be bidirectional safely?
Answer: technically yes, but it increases complexity significantly. Without strict governance, bidirectional sync often leads to data overwrites and inconsistency.
Follow-up 2. Why do integrations amplify this problem?
Answer: interfaces may update customer or vendor records directly, bypassing BP. This breaks the intended data flow and introduces conflicting updates.
Follow-up 3. Curveball. Why do some projects discover this only during audit?
Answer: audits compare data consistency across systems. Synchronization drift may not affect day-to-day transactions, but becomes visible when data is reconciled at scale.
Exclusive pro tip 1. Doran.
If master data can be changed from multiple entry points, synchronization will eventually fail. Enforce a single entry door.
Scenario 34. Updating business partner. When direct table updates corrupt the system.
After migration to S/4HANA, a developer attempts to update customer address data using a familiar ECC approach. The program activates successfully, but during testing, address changes either do not persist, revert unexpectedly, or cause CVI errors. In some cases, postings fail days later with cryptic master data inconsistencies.
The real reason for failure.
This failure is caused by violating the business partner ownership model. 1. In ECC, developers often updated KN1 or LF1 directly. 2. In S/4HANA, business partner is the leading object. 3. Customer and vendor tables are derived representations. 4. Direct table updates bypass synchronization and validation logic. Here is a BAP code showing a legacy direct table update that silently breaks business partner consistency. Disclaimer: always test code in a non-production environment. Here is the legacy read pattern. The developer assumes KN1 is the authoritative customer table, which is no longer true in S/4HANA. This line of code is the core violation. It updates a derived table directly, bypassing business partner validation and synchronization. This commit finalizes inconsistent data. The error may not appear immediately, but downstream processes will eventually fail.
The fix, the interview-winning answer.
A senior architect frames this as respecting object ownership. 1. Never update KN1 or LF1 directly in S/4HANA. 2. Treat business partner as the single source of truth. 3. Use released BP APIs to perform updates. 4. Allow CVI to propagate changes to customer and vendor views. 5. Validate changes using BP transactions, not table checks. This answer demonstrates mastery of S/4HANA master data governance. Here is a BAP code showing correct business partner update using the CVI inbound API. Disclaimer: always test code in a non-production environment. Here is the key shift. The update targets the business partner, not the customer or vendor number. This code snippet uses SAP's released CVI API. It enforces validation, consistency, and synchronization automatically. The commit now finalizes a consistent update that propagates correctly across all dependent objects.
Follow-up 1. Why does direct table updates sometimes appear to work?
Answer: because compatibility tables still exist. The update may succeed technically, but leaves business partner data unchanged, creating hidden inconsistencies.
Follow-up 2. Why is CVI API considered mandatory?
Answer: because it enforces SAP's ownership rules. It guarantees that BP, customer, and vendor views remain synchronized.
Follow-up 3. Curveball. Why do BP-related issues often surface in finance first?
Answer: because postings depend on consistent master data. Finance transactions are usually the first to validate BP integrity at scale.
Exclusive pro tip. Ban update on KN01.
In S/4HANA projects, enforce a hard rule. Any update on KN01 or LF01 is a defect, not a shortcut.
Scenario 35. Querying BUT000 when you need identity, not roles.
After moving to the business partner model, developers struggle with a simple requirement: fetching basic master data such as name, address reference, or BP category. Many still attempt to read KN01 or LF01 and get incomplete or misleading results.
The real reason for failure.
This issue is caused by querying role-specific tables for identity-level data. 1. Business partner is the leading object in S/4HANA. 2. Identity-level attributes live in BUT000. 3. Customer and vendor tables only contain role-specific fields. 4. Querying KN01 or LF01 misses cross-role identity data. Here is a BAP code using customer tables to fetch identity data. Legacy approach. Disclaimer: always test code in a non-production environment. Here is the legacy assumption. The developer treats KN01 as the identity table, which is no longer correct in S/4HANA. Here is a BAP code reading identity data directly from the business partner table. Disclaimer: always test code in a non-production environment. This code snippet accesses the business partner identity directly. It works regardless of whether the partner acts as a customer, vendor, or both.
When to use BUT000 versus role tables.
Use BUT000 when you need identity-level information such as name, category, or central attributes. Use role tables only when role-specific data is explicitly required.
The fix: the interview-winning answer.
A senior architect explains this as correct data modeling. 1. Identify whether the requirement is identity-based or role-based. 2. Query BUT000 for identity data. 3. Avoid using KN01 or LF01 as identity sources. 4. Design reports and interfaces around the BP model.
Follow-up 1. Does BUT000 replace KN01 and LF01 completely?
Answer: no. BUT000 holds identity data. Role-specific fields still reside in customer and vendor tables.
Follow-up 2. What happens if a BP has both customer and vendor roles?
Answer: BUT000 remains the single identity record. Role tables simply extend it.
Follow-up 3. Curveball. Why do some interfaces still read KN01?
Answer: because they were migrated without redesign. These interfaces often break when partners gain additional roles.
Exclusive pro tip: identity-first queries.
If your select does not start from BUT000, question whether you are modeling the problem correctly.
Section 6 complete. Master data is now an architecture problem.
Section 6 exposed a critical truth of S/4HANA. Master data failures are no longer isolated. A single business partner inconsistency can break finance, logistics, and integrations simultaneously. Projects that treat business partner as a technical migration task usually succeed in conversion, but fail in operations. In S/4HANA, master data is governed by design decisions, not patches.
Now we face custom logic.
So far, we addressed data and architecture. But most S/4HANA projects collapse under something far more dangerous: custom enhancements that nobody fully understands anymore. This is where legacy creativity meets modern extensibility, and not all of it survives.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S/4HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Section 7. Enhancements and custom logic, from modifications to extensibility.
S/4HANA did not remove enhancements. It redefined how and where custom logic is allowed. Procedural exits and direct modifications are replaced with controlled, object-oriented extension points. This section focuses on enhancement-related failure modes that compile successfully, but violate S/4HANA's extensibility model.
Scenarios covered in this category.
36. User exits versus BAD is procedural versus object-oriented enhancements. 37. In-app extensibility versus classic enhancements. 38. Side-by-side extensibility BTP. 39. Implicit enhancements and their survival. 40. Replacing modification assistant code. This category exposes whether custom logic is future-proof or already obsolete.
Scenario 36. User exits versus BAD is when procedural logic collides with object orientation.
After migrating to S/4HANA, a long-standing enhancement that modifies document behavior suddenly behaves inconsistently. Sometimes the logic runs, sometimes it does not. Developers find no syntax errors, but the behavior differs across transactions and system upgrades.
The real reason for failure.
This failure is caused by mixing procedural and object-oriented enhancement models. 1. User exits rely on implicit procedural execution points. 2. They assume a fixed call sequence in SAP standard programs. 3. S/4HANA refactors many standard programs internally. 4. BAD is provide explicit, contract-based enhancement points. Here is a BAP code showing a legacy user exit that relies on implicit execution order. Disclaimer: always test code in a non-production environment. Here is the procedural user exit entry point. It assumes SAP will always call this form at the same point in the transaction flow. This code snippet relies on global variables being populated in a specific order, which is not guaranteed after S/4HANA refactoring.
The fix, the interview-winning answer.
A senior architect reframes this as an extensibility strategy decision. 1. Stop relying on procedural user exits for new logic. 2. Identify the corresponding released BAD. 3. Implement enhancements using object-oriented contracts. 4. Avoid global variable dependencies. 5. Design enhancements to survive SAP internal refactoring. This answer demonstrates understanding of SAP's extensibility evolution. Here is a BAP code showing the same logic implemented using a released B-add-I. Disclaimer: always test code in a non-production environment. Here is the explicit enhancement contract. SAP guarantees when and how this method is called. This code snippet modifies data through parameters, not global variables, making behavior deterministic and upgrade safe.
Follow-up 1. Do all user exits need to be replaced?
Answer: no. Existing exits may still work, but new logic should not be added. Over time, procedural exits become brittle as SAP refactors standard code.
Follow-up 2. Why are B-add is more stable?
Answer: because they define explicit interfaces. SAP commits to these contracts, even when internal implementations change.
Follow-up 3. Curveball. Why do some exits break only after support packs?
Answer: because implicit call points are not protected. Support packs may reorder or remove them without warning.
Exclusive pro tip. Exit survival test.
If you cannot explain exactly when and why your enhancement runs, it will eventually fail in S/4HANA.
Scenario 37. In-app extensibility versus classic enhancements. When custom code blocks innovation.
After moving to S/4HANA, the business asks for small changes: add a field to a screen, add logic to default a value, or expose a field in a report. The development team responds with classic enhancements or custom code. Months later, upgrades become painful and Fiori apps cannot be adapted cleanly.
The real reason for failure.
This failure is caused by choosing the wrong extensibility model. 1. Classic enhancements assume full control over SAP standard. 2. S/4HANA introduces in-app extensibility for key user adaptations. 3. Not every requirement justifies custom ABAP code. 4. Over-customization blocks upgrades and innovation.
Why this breaks long-term roadmaps.
When simple business requirements are solved with classic enhancements, the system becomes rigid. Innovation scenarios like Fiori extensibility, analytics, and cloud integration become harder with each customization.
The fix, the interview-winning answer.
A senior architect explains this as an extensibility governance decision. 1. Classify requirements by complexity and stability. 2. Use in-app extensibility for UI fields, validations, and simple logic. 3. Reserve classic enhancements for deep core logic only. 4. Align extensibility choices with SAP's clean core strategy. 5. Continuously review and retire unnecessary custom code.
Follow-up 1. Why does SAP push in-app extensibility so strongly?
Answer: because it allows upgrades without breaking customer logic. In-app changes are upgrade safe by design.
Follow-up 2. Is in-app extensibility too limited for real projects?
Answer: it is intentionally limited. It covers the majority of business adaptation needs without risking system stability.
Follow-up 3. Curveball. Why do developers often resist in-app extensibility?
Answer: because it shifts power from code to configuration. Senior architects understand that restraint is a design skill.
Exclusive pro tip. Clean core is a behavior.
Clean core is not achieved by deleting code. It is achieved by choosing not to write code when it is unnecessary.
Scenario 38. Side-by-side extensibility. When custom logic no longer belongs in ABAP.
After migrating to S/4HANA, new requirements emerge that were never considered in ECC: AI scoring, complex integrations, real-time analytics, and external orchestration. Teams instinctively try to implement everything inside ABAP, and the core system slowly becomes overloaded again.
The real reason for failure.
This failure is caused by forcing all logic into the digital core. 1. ECC encouraged centralizing logic inside the ABAP stack. 2. S/4HANA introduces side-by-side extensibility using SAP BTP. 3. Not all logic belongs in the transactional core. 4. Heavy custom logic increases upgrade and scaling risk.
Why this is an architectural shift.
Side-by-side extensibility separates transactional stability from innovation velocity. The core remains clean and stable, while new capabilities evolve independently.
The fix, the interview-winning answer.
A senior architect frames this as a system boundary decision. 1. Keep transactional integrity inside S/4HANA. 2. Move complex, non-transactional logic to SAP BTP. 3. Integrate via APIs and events. 4. Design extensions to scale independently. 5. Protect the core from innovation churn.
Follow-up 1. When should logic stay inside S/4HANA?
Answer: when it directly affects transactional consistency, postings, or legal documents. Core logic must remain close to the data.
Follow-up 2. Why not just write everything in ABAP?
Answer: because ABAP was designed for transactional processing, not elastic scaling or AI workloads. Forcing it to do everything reduces system resilience.
Follow-up 3. Curveball. Why do side-by-side projects often fail initially?
Answer: because teams treat BTP as a technical add-on instead of a product platform. Governance and ownership are often unclear at the start.
Exclusive pro tip. Innovation has a different life cycle.
If a requirement changes every quarter, it does not belong in the core system.
Scenario 39. Implicit enhancements. When your logic quietly stops running.
After a support pack or S/4HANA upgrade, a piece of custom logic suddenly stops working. There are no syntax errors, no dumps, and no transport issues. The enhancement is still active, but the business behavior has changed.
The real reason for failure.
This issue is caused by reliance on implicit enhancement points. 1. Implicit enhancements are tied to specific positions in standard code. 2. SAP refactors standard programs during upgrades. 3. Implicit enhancement anchors can move or disappear. 4. The enhancement remains active but is never executed. Here is ABAP code implemented as an implicit enhancement in ECC. Disclaimer: always test code in a non-production environment. Here is the implicit enhancement block. It depends entirely on SAP's internal code structure remaining unchanged. Here is the same implicit enhancement after S/4HANA refactoring. Disclaimer: always test code in a non-production environment. This code snippet shows the silent failure. The enhancement exists but is never reached due to refactored standard logic.
Why this is so dangerous?
Implicit enhancements fail silently. There is no runtime error, no syntax warning, and no obvious trace. The business impact is discovered only through incorrect behavior.
The fix, the interview-winning answer.
A senior architect treats implicit enhancements as temporary hacks. 1. Inventory all implicit enhancements before migration. 2. Replace them with explicit enhancement points or BAD-is. 3. Avoid adding new implicit enhancements in S/4HANA. 4. Test enhancement execution paths after every upgrade. 5. Treat silent failures as critical defects.
Follow-up 1. Why do implicit enhancements still exist if they are risky?
Answer: they exist for backward compatibility and edge cases. SAP discourages their use for core logic.
Follow-up 2. How can teams detect broken implicit enhancements?
Answer: by adding temporary logging or breakpoints during testing and monitoring behavior after upgrades.
Follow-up 3. Curveball. Why are implicit enhancements rarely documented?
Answer: because they were often added under time pressure. Documentation was sacrificed for speed.
Exclusive pro tip. Silence is a symptom.
If logic stops running without errors after an upgrade, implicit enhancements are the first place to look.
Scenario 40. Modification assistant. When your changes are technically gone but logically still there.
After completing the S/4HANA conversion, a team discovers that some custom behavior has disappeared. There are no syntax errors, no dumps, and no failed transports. Yet, business users insist that certain custom logic no longer executes.
The real reason for failure.
This failure is caused by relying on SAP standard modifications. 1. Modifications overwrite SAP standard code. 2. During upgrades, SAP replaces modified objects with new versions. 3. The modification assistant attempts to reapply changes. 4. Conflicts are often resolved incorrectly or deferred.
Why this is a time bomb.
Modifications create hidden dependencies on SAP internal implementation. Each upgrade increases the risk that custom logic will be dropped, partially applied, or behave differently than before.
The fix, the interview-winning answer.
A senior architect treats modifications as technical debt. 1. Eliminate modifications wherever possible. 2. Replace them with released enhancement points or BAD-is. 3. Use the modification assistant only as a temporary bridge. 4. Document all remaining modifications explicitly. 5. Plan modification retirement as part of every upgrade.
Follow-up 1. Why were modifications so common in ECC?
Answer: because enhancement frameworks were limited. Modifications were often the only way to meet urgent business needs.
Follow-up 2. Can modifications ever be justified in S/4HANA?
Answer: only in exceptional cases and with explicit governance approval. They should never be the default choice.
Follow-up 3. Curveball. Why do some modifications survive for years unnoticed?
Answer: because they touch rarely used code paths. They only surface during upgrades or when new business scenarios activate those paths.
Exclusive pro tip. Modifications age badly.
If a piece of custom logic requires the modification assistant to survive, it is already a liability.
Section 7 complete. Custom logic must earn its place.
Section 7 exposed a critical reality of S/4HANA. Custom logic is no longer free. Every enhancement choice has consequences for upgrades, performance, and long-term maintainability. Teams that survive S/4HANA do not eliminate custom logic, they control it. Extensibility becomes a design discipline, not a reflex.
Now we talk about what the business actually sees.
So far, we focused on data, logic, and architecture. But many go-live escalations are triggered by something far more visible: outputs that no longer look or behave the same. Forms, messages, and interfaces are where technical mistakes become business incidents.
Section 8. Forms and output management. When documents break trust.
Output management is not just about formatting. It is about legal documents, customer communication, and operational continuity. S/4HANA modernizes output architecture and breaks legacy assumptions in the process. This section focuses on output-related failure modes that compile successfully, but fail in production usage.
Scenarios covered in this category.
41. Smart forms and SAP script compatibility. 42. BRF plus versus in a CE output control. 43. Adobe Forms as the S/4HANA standard. 44. IDOC structure changes and extensions. 45. File interfaces, a L11 versus cloud. Output failures are business visible failures.
Scenario 41. Smart forms and SAP script. When outputs still work, until they don't.
After migrating to S/4HANA, existing smart forms and SAP script outputs continue to print correctly. The project team assumes output management is unaffected and moves on. Weeks later, performance issues appear. New output requirements cannot be implemented cleanly, and SAP notes warn about deprecated technologies.
The real reason for failure.
This failure is caused by confusing compatibility with strategic support. 1. Smart forms and SAP script are still supported in S/4HANA. 2. They are not the strategic direction for output management. 3. New output frameworks integrate poorly with legacy forms. 4. Long-term innovation assumes Adobe Forms and BRF+.
Why this hits late in projects.
Output issues often surface after functional testing, when new legal requirements, layout changes, or performance constraints appear. By then, the cost of rework is high.
The fix, the interview-winning answer.
A senior architect frames this as a modernization decision. 1. Allow existing smart forms to run temporarily. 2. Do not invest in new smart forms or SAP script. 3. Plan migration to Adobe Forms for critical outputs. 4. Align output strategy with BRF+ and S/4HANA roadmap. 5. Treat legacy forms as technical debt.
Follow-up 1. Why does SAP still support smart forms?
Answer: to protect customer investments. Support does not imply strategic relevance.
Follow-up 2. Is migrating all forms mandatory?
Answer: no. Only business-critical or frequently changed outputs should be modernized first.
Follow-up 3. Curveball. Why do output performance issues increase in S/4HANA?
Answer: because data volumes increase and legacy form logic often performs row-by-row processing instead of set-based access.
Exclusive pro tip. Output is a roadmap topic.
If you treat output management as a technical afterthought, the business will treat your go-live as a failure.
Scenario 42. BRF+ versus and a CE. When output control stops obeying your conditions.
After S/4HANA migration, output determination for invoices and delivery notes behaves inconsistently. The old N/A/CE condition records exist, but outputs are not triggered. Consultants spend days debugging driver programs and message types, unaware that the entire output control engine has changed.
The real reason for failure.
This failure occurs because legacy output control in a CE was replaced by BRF Plus in S4 HANA. 1. S4 HANA introduces a new framework called BRF Plus, Business Rule Framework Plus. 2. In a CE-based condition technique is still visible but inactive for new output types. 3. Custom programs that call old NAST tables or output driver routines bypass the new logic. 4. BRF Plus uses decision tables, XML templates, and event-driven triggers instead of condition records. Most project teams assume NACE still drives output. It doesn't. It only appears as a compatibility shell.
Why this is confusing.
S4 HANA still includes transaction and a CE for backward compatibility, but it no longer controls output for standard applications such as billing, SD, purchase orders, MM, or delivery documents, LA. This dual visibility leads consultants to configure the wrong framework entirely.
The fix, the interview-winning answer.
A senior architect always links the fix to architectural governance. 1. Recognize BRF Plus as the default output management framework in S4 HANA. 2. Migrate existing NACE configurations only if the application still supports it. 3. For new developments, design BRF Plus decision tables and rules instead of condition records. 4. Train functional teams to manage BRF Plus applications directly, not via transport imports. 5. Treat BRF Plus as part of business configuration, not as ABAP logic.
Follow-up 1. Is NACE completely obsolete now?
Answer: not entirely. Some industry-specific modules or custom driver programs may still depend on it. However, for standard billing and purchasing outputs, SAP has officially moved to BRF Plus as the primary engine.
Follow-up 2. Why do BRF Plus outputs often fail in production even when testing works?
Answer: because the BRF Plus application transport was incomplete or the communication channel, for example, output type mail, was not configured in the target system. BRF Plus depends on both the rule logic and output parameters being consistent across clients.
Follow-up 3. Curveball. Why do developers dislike BRF Plus initially?
Answer: because it removes control from code and pushes it into configuration. Senior developers must now collaborate with functional consultants to modify output logic, which feels slower initially but reduces long-term maintenance risk.
Exclusive pro tip. BRF Plus is not a replacement, it's an evolution.
If your output logic still depends on NAST or driver program routines, you are running legacy output management in a modern system. Move to BRF Plus before SAP forces the deprecation.
Scenario 43. Adobe Forms. Why S4 HANA standardized output requires a new runtime?
After S4 HANA migration, output generation technically works, but new requirements like interactive fields, digital signatures, or email-based outputs become difficult or impossible to implement using legacy smart forms or SAP script.
The real reason for failure.
The failure is not caused by quick fixes themselves, but by blind trust in automation. 1. Smart forms and SAP script rely on older spool-based rendering. 2. S4 HANA standard output frameworks expect PDF-based rendering. 3. Modern compliance and UX requirements demand interactive documents. 4. Adobe Forms integrate natively with BRF Plus and output management. Here is ABAP code showing legacy smart form output generation. Disclaimer: always test code in a non-production environment. Here is the legacy smart form execution pattern. It depends on spool-based output and tightly coupled form logic, which limits flexibility in S4 HANA. Here is ABAP code showing Adobe Form output generation in S4 HANA. Disclaimer: always test code in a non-production environment. Here is the Adobe Forms runtime pattern. It initializes a form job context, supports PDF rendering, and integrates cleanly with output management.
The fix, the interview-winning answer.
A senior architect explains this as a standardization and compliance decision. 1. Adopt Adobe Forms as the default output technology in S4 HANA. 2. Keep smart forms only for legacy stability, not for new development. 3. Align output strategy with BRF Plus output management. 4. Enable interactive, compliant, and digital-ready documents. 5. Reduce long-term technical debt in output processing. This answer positions you as an architect who prioritizes long-term governance over short-term convenience.
Follow-up 1. Are Adobe Forms mandatory in S/4HANA?
Answer: they are not technically mandatory, but they are the strategic standard. SAP innovations around output management assume Adobe Forms.
Follow-up 2. Why do Adobe Forms feel more complex initially?
Answer: because they separate data, layout, and rendering. This adds setup overhead but dramatically improves flexibility and governance.
Follow-up 3. Curveball. Why do Adobe Forms reduce audit risks?
Answer: because PDFs are immutable, traceable, and support digital signatures, which are critical for compliance and legal documents.
Exclusive pro tip. Output is a compliance topic.
If your output cannot be digitally signed or archived securely, it is already non-compliant, regardless of how good it looks.
Scenario 44. IDOC structure changes when interfaces break without syntax errors.
After S/4HANA migration, inbound and outbound IDOCs are generated successfully, but downstream systems start rejecting them. There are no dumps, no IDOC errors in V02, and yet business integrations silently fail.
The real reason for failure.
This failure is caused by structural changes in standard IDOCs. 1. S/4HANA modifies standard IDOC segments and field lengths. 2. Custom extensions rely on hard-coded segment positions. 3. Downstream systems expect the old segment layout. 4. Syntax checks do not detect semantic incompatibility. Here is a BAP code showing a legacy IDOC extension using hard-coded segment access. Disclaimer: always test code in a non-production environment. Here is the risky part of the code. It assumes a fixed field offset inside the segment, which often changes in S/4HANA. Here is a BAP code showing IDOC processing using structure-based access. Disclaimer: always test code in a non-production environment. Here is the safe approach. Assigning S data to a typed structure ensures field alignment even when SAP changes the segment layout.
The fix, the interview-winning answer.
A senior architect treats IDOCs as contracts, not byte streams. 1. Never access S data using offsets. 2. Always map S data to a typed segment structure. 3. Validate IDOC changes with partner systems. 4. Version IDOC interfaces explicitly. 5. Treat integration changes as cross-team deliverables.
Follow-up 1. Why does this issue not show up in V02?
Answer: because the IDOC syntax is valid. The failure occurs at the semantic or partner system level.
Follow-up 2. Do all IDOCs change in S/4HANA?
Answer: not all, but many standard IDOCs evolve. You must validate each critical interface.
Follow-up 3. Curveball. Why do IDOC issues often appear weeks after go-live?
Answer: because some partners process IDOCs asynchronously, or only during month-end cycles.
Exclusive pro tip. Byte offsets are technical debt.
If your IDOC logic depends on S data offsets, it is guaranteed to break eventually.
Scenario 45. File interfaces. When a L11 logic breaks in a cloud-first world.
After migrating to S/4HANA, a nightly interface that exports financial or logistics data suddenly fails. In ECC, the job wrote files to the application server using a L11 paths, and downstream systems picked them up. In S/4HANA, the job runs, but no file appears, or worse, it works in DEV but fails in QA and prod.
The real reason for failure.
This failure is caused by assuming that the application server file system is stable and accessible. 1. ECC systems typically ran on on-premise servers with shared file systems. 2. Custom ABAP programs freely used open dataset with hard-coded paths. 3. S/4HANA increasingly runs in virtualized or cloud environments. 4. Local file systems may be read-only, isolated, or not shared across instances. Here is a BAP code showing a legacy file interface that relies on a L11 and application server paths. Disclaimer: always test code in a non-production environment. Here is the first architectural assumption. This hard-coded path assumes a shared, writable file system across all application servers. Here is the legacy file access pattern. In cloud or HA setups, this path may not exist, may be read-only, or may point to a local container. This code snippet silently assumes that downstream systems can access the same physical location, which is no longer guaranteed.
The fix, the interview-winning answer.
A senior architect reframes this as an integration boundary problem. 1. Stop treating the application server file system as an integration mechanism. 2. Use logical file paths and file transactions only as a temporary bridge. 3. Move file handling to managed services like SAP Application Interface Framework or SAP BTP. 4. Use APIs, SFTP, or object storage instead of local directories. 5. Design interfaces assuming stateless application servers. This answer demonstrates cloud readiness, integration maturity, and operational awareness. Here is a ABAP code showing cloud-safe file handling using logical file names. Disclaimer: always test code in a non-production environment. Here is the abstraction layer. Logical file names decouple code from physical paths, allowing environment-specific configuration. This code snippet still writes a file, but now respects system configuration and security boundaries. The business logic remains unchanged, but the interface is now deployable across DEV, QA, and prod consistently.
Follow-up 1. Is open dataset forbidden in S/4HANA?
Answer: no, it is not forbidden. However, its use must be carefully governed. In cloud or HA environments, local file access is unreliable and should not be used for system integration.
Follow-up 2. Why do file interfaces often fail only in production?
Answer: because production systems are typically load balanced across multiple instances. Files written to one instance are invisible to others, causing intermittent failures.
Follow-up 3. Curveball. Why do cloud-native projects avoid files completely?
Answer: because files introduce state. Cloud-native architectures favor stateless services with explicit data exchange via APIs or events.
Exclusive pro tip. Files are an anti-pattern.
If your interface depends on a shared folder, it will eventually break under scale, security, or cloud migration.
Section 8 complete. Output failures are business failures.
Section 8 highlighted one of the most underestimated risks in S/4HANA projects. When outputs fail, invoices do not go out, deliveries are blocked, and trust with customers erodes immediately. Teams that survive S/4HANA do not just migrate outputs. They modernize output architecture deliberately.
Now we enter modern ABAP.
Up to this point, most failures came from legacy assumptions. From here on, success depends on whether developers can think in set-based, database-driven, and service-oriented patterns. This is where S/4HANA stops being an upgrade and becomes a skill reset.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S/4HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers. 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Section 9, Modern ABAP, the skills gap that breaks projects.
S/4HANA did not just change tables and transactions. It introduced a new way of thinking about performance, data access, and application design. This section focuses on failure modes caused by using ECC-era coding style in a HANA-optimized world.
Scenarios covered in this category.
46. AMDP when SQL belongs in the database, not in ABAP loops. 47. CDS views basic versus composite versus consumption. 48. Inline declarations and new ABAP syntax. 49. RAP model RESTful ABAP programming. 50. ALV-ID for HANA-optimized reporting. These scenarios expose the real ABAP skill gap in S/4HANA programs.
Scenario 46, AMDP, when loop-based ABAP logic hits a performance wall.
After migrating to S/4HANA, a custom report that calculates sales KPIs starts timing out in production. The code uses nested loops and multiple select statements. It worked acceptably in ECC, but on HANA the runtime explodes as data volume increases.
The real reason for failure.
This failure is caused by ignoring SAP HANA's execution model. 1. ECC-era ABAP relied heavily on row-by-row processing. 2. Nested loops trigger massive data transfer between database and application server. 3. SAP HANA is optimized for set-based operations inside the database. 4. Moving data out of HANA defeats its performance advantages. Here is ABAP code showing a loop-based KPI calculation that performs poorly on HANA. Disclaimer: always test code in a non-production environment. Here is the main performance problem. This loop forces one database call per sales order, multiplying execution time with data volume. This code snippet triggers repeated round trips between ABAP and the database, completely negating HANA's strengths.
The fix, the interview-winning answer.
A senior architect reframes this as a code pushdown decision. 1. Identify logic that can be executed set-based. 2. Move aggregation logic into the database. 3. Use AMDP for complex SQL logic not expressible in OpenSQL. 4. Minimize data transfer between database and ABAP layer. 5. Measure performance impact before and after pushdown. This answer demonstrates HANA-first thinking and performance maturity. Here is ABAP code showing KPI calculation implemented using AMDP. Disclaimer: always test code in a non-production environment. Here is the AMDP declaration. This explicitly tells SAP that the logic runs inside the HANA database. This code snippet performs aggregation directly in HANA, eliminating all ABAP loops and round trips.
Follow-up 1. Why not use OpenSQL instead of MDP?
Answer: OpenSQL should be the first choice. AMDP is justified when logic becomes too complex or performance-critical for OpenSQL expressions.
Follow-up 2. Does AMDP lock you into SAP HANA?
Answer: yes, intentionally. S/4HANA is HANA only, so AMDP leverages that guarantee instead of avoiding it.
Follow-up 3. Curveball. Why do some AND perform worse than ABAP?
Answer: because poorly written SQL script can cause full table scans or inefficient joins. Pushdown without understanding data models is dangerous.
Exclusive pro tip: push down with intent.
AMDP is not about moving code blindly to the database. It is about placing logic where it executes most efficiently.
Scenario 47, CDS views, when reports fail because the data model is wrong.
After migrating to S/4HANA, a custom financial and sales report becomes slow and inconsistent. Developers attempt to optimize it by adding indexes or rewriting select statements, but performance remains unstable. The root cause is not the SQL, it is the absence of a proper data model.
The real reason for failure.
This failure is caused by treating reports as isolated SQL problems instead of modeled data services. 1. ECC reports were built directly on tables with procedural joins. 2. S/4HANA introduces core data services, CDS, as the semantic layer. 3. Without CDS, every report reimplements joins, filters, and calculations. 4. Performance and consistency degrade as logic is duplicated. Here is a BAP code showing a classic report built directly on tables without a semantic data model. Disclaimer: always test code in a non-production environment. Here is the procedural join embedded inside the report. Every report that needs sales data must repeat this logic. This filter is applied at runtime, but there is no reusable semantic definition for what constitutes a valid reporting period.
The fix, the interview-winning answer.
A senior architect reframes this as a data modeling problem. 1. Introduce CDS as the canonical data access layer. 2. Separate data modeling from consumption. 3. Define joins, filters, and semantics once. 4. Reuse CDS views across reports and services. 5. Enable database-level optimization and caching. This answer demonstrates architectural maturity and long-term scalability thinking. Here is a BAP CDS code defining a reusable sales data model. Disclaimer: always test code in a non-production environment. Here is the CDS definition. It establishes a reusable semantic layer instead of embedding joins in reports. This annotation integrates authorization logic directly into the data model, ensuring consistent security. Here is a BAP code consuming the CDS view instead of raw tables. Disclaimer: always test code in a non-production environment. This code snippet shows clean consumption. The report no longer cares how the data is joined or secured.
Follow-up 1. Why not build everything directly in CDS?
Answer: CDS is for data modeling, not full business logic. Complex transactional logic still belongs in a BAP or services.
Follow-up 2. What is the difference between basic and consumption CDS?
Answer: basic views model core data. Consumption views shape data for specific use cases like analytics or APIs.
Follow-up 3. Curveball. Why do poorly designed CDS views perform worse than a BAP?
Answer: because excessive joins, missing filters, or wrong cardinalities can cause expensive execution plans at the database level.
Exclusive pro tip. CDS is a contract.
Once other teams consume your CDS view, changing it without governance is as dangerous as changing a public API.
Scenario 48. Inline declarations. When legacy declarations hide real bugs.
After S/4HANA migration, developers begin mass remediating code using quick fixes in Eclipse ADT. Inline declarations appear everywhere. The code activates and runs, but subtle bugs start appearing during refactoring and transport merges.
The real reason for failure.
This failure is caused by misunderstanding what inline declarations actually change. 1. ECC-era code declared variables at the top of programs or forms. 2. Inline declarations bind variable scope to execution context. 3. Developers assume inline declarations are purely cosmetic. 4. Scope and lifetime bugs appear during refactoring. Here is a BAP code using classic top-level declarations. Disclaimer: always test code in a non-production environment. Here is the classic declaration style. The variable exists for the entire program or form, regardless of where it is used. Here is a BAP code using inline declaration with limited scope. Disclaimer: always test code in a non-production environment. Here is the inline declaration. The variable now exists only in this execution context, which improves safety but changes scope behavior.
The fix, the interview-winning answer.
A senior architect treats inline declarations as a design tool, not a shortcut. 1. Use inline declarations to limit variable scope intentionally. 2. Avoid inline declarations in deeply nested logic without clarity. 3. Be cautious during mass quick fix refactoring. 4. Prefer readability over brevity in critical logic. 5. Review scope changes during code reviews.
Follow-up 1. Why does SAP promote inline declarations?
Answer: because they reduce variable lifetime, lower side effects, and make code easier to reason about when used correctly.
Follow-up 2. Can inline declarations cause runtime errors?
Answer: indirectly, yes. When developers assume broader scope than actually exists, refactoring can introduce logic gaps.
Follow-up 3. Curveball. Why do inline declarations improve parallel safety?
Answer: because smaller variable scope reduces shared state, which is critical when logic evolves toward parallel execution patterns.
Exclusive pro tip. Scope is a design decision.
Inline declarations are powerful precisely because they force you to think about where a variable should exist, not just how fast you can write code.
Scenario 49, RAP model, when classical ABAP cannot support modern apps.
After moving to S/4HANA, the business requests a Fiori app for maintaining custom business objects. The development team responds by building a classic function module and a custom OData service. The app works initially, but authorization, validation, draft handling, and upgrades quickly become unmanageable.
The real reason for failure.
This failure is caused by using a procedural service mindset in a service-oriented platform. 1. Classic ABAP exposes logic first, not business behavior. 2. OData services built manually duplicate validation and authorization logic. 3. Fiori applications expect draft handling, locking, and transactional consistency. 4. S/4HANA introduces RAP as the standard programming model. Here is ABAP code showing a classic function module-driven service approach. Disclaimer: always test code in a non-production environment. Here is the core problem. The update logic is exposed directly without behavior control, validation framework, or draft support. This code snippet forces a commit inside the logic, breaking transactional consistency when consumed by services.
The fix, the interview-winning answer.
A senior architect reframes this as a behavior-centric design decision. 1. Adopt RAP for transactional business objects. 2. Separate data, behavior, and service exposure. 3. Use managed behavior for standard CRUD scenarios. 4. Leverage RAP for draft handling and locking automatically. 5. Align application design with SAP's strategic roadmap. This answer demonstrates service orientation, clean architecture, and future-proof thinking. Here is ABAP RAP code defining behavior instead of procedural logic. Disclaimer: always test code in a non-production environment. Here is the RAP shift. Instead of writing update logic, we declare allowed business behavior. This code snippet shows declarative validation. RAP ensures it runs consistently for all consumers. Here is ABAP code implementing RAP validation logic safely. Disclaimer: always test code in a non-production environment. Here is the control data access pattern. RAP manages transactional consistency automatically. This snippet shows how RAP reports validation errors consistently to all consumers.
Follow-up 1. Do we need RAP for every custom object?
Answer: no. RAP is ideal for transactional business objects exposed to UIs or services. Simple reports or background logic may not require it.
Follow-up 2. Why not continue using classic SEGWO data?
Answer: because SEGW requires manual handling of validation, authorization, draft, and consistency. RAP provides these by design.
Follow-up 3. Curveball. Why does RAP feel restrictive to senior developers?
Answer: because it enforces discipline. RAP removes low-level control in exchange for consistency, scalability, and upgrade safety.
Exclusive pro tip: behavior beats code.
If you start a design discussion by asking where do I write the update logic, you are already thinking pre-RAP.
Scenario 50, ALV IDA, when classical ALV becomes a performance bottleneck.
After migrating to S/4HANA, a large analytical report starts running slowly or timing out. The logic is correct, and the database is fast, but users experience delays when displaying results. Developers attempt to optimize select statements, but the UI remains sluggish.
The real reason for failure.
This failure is caused by using a row-based UI renderer on a column store database. 1. Classical ALV loads full datasets into application server memory. 2. Large result sets cause memory pressure and transfer overhead. 3. SAP HANA is optimized for on-demand column-based access. 4. ALV ID delegates paging, sorting, and filtering to the database. Here is ABAP code showing classical ALV rendering for large datasets. Disclaimer: always test code in a non-production environment. Here is the critical limitation. The entire dataset is transferred to the application server before rendering, regardless of how much the user actually views. Here is ABAP code showing ALV ID, for HANA-optimized reporting. Disclaimer: always test code in a non-production environment. Here is the ALV ID factory call. Data is fetched lazily from HANA only when the user scrolls or filters.
The fix, the interview-winning answer.
A senior architect treats reporting as a database-driven use case. 1. Use ALV-ID for large analytical datasets. 2. Base ALV-ID on CDS views whenever possible. 3. Avoid loading full datasets into ABAP memory. 4. Delegate sorting and filtering to HANA. 5. Choose UI technology based on data volume.
Follow-up 1. Is ALV-ID a replacement for all ALV reports?
Answer: no. Classical ALV is still suitable for small datasets or highly customized UI logic. ALV-ID shines when data volume is high.
Follow-up 2. Why does ALV-ID require HANA?
Answer: because it relies on database-driven paging and filtering, which only HANA can guarantee with acceptable performance.
Follow-up 3. Curveball. Why do some ALV-ID reports feel slower initially?
Answer: because initial metadata and CDS authorization checks occur upfront. Once loaded, interaction performance is significantly better.
Exclusive pro tip. UI performance starts at the database.
If your report UI feels slow, the problem is often not the select. It is the rendering strategy.
Section 9 complete. Modern ABAP is a mindset shift.
Section 9 demonstrated that S/4HANA performance and scalability are not achieved by optimizations alone. They require a fundamental change in how developers model data, design services, and think about execution. Teams that fail here usually blame HANA. Teams that succeed change how they write ABAP.
Now we enter the most dangerous phase.
Even perfectly written code can fail during go-live. Runtime behavior, authorizations, and cutover mistakes are where most S/4HANA projects lose credibility. This final section focuses on failures that happen under pressure, not in development.
Section 10. Runtime and cutover, where good projects break.
Cutover is not a technical step. It is a stress test. Authorizations, background jobs, low and transport timing decide whether a system survives its first business day. This section covers failure modes that only appear at scale, under real user load.
Scenarios covered in this category.
51. Authorization failures with CDS and DCL. 52. Background jobs after migration. 53. LUW and commit work pitfalls. 54. Retrofit strategy failures. 55. ABAP unit in S/4HANA. 56. SPDD and SPAU during cutover. These are the failures that surface when the system goes live.
Scenario 51. Authorization checks with CDS and DCL, when users suddenly lose access.
After go live on S/4HANA, users complain that reports and Fiori apps return no data. There are no dumps, no SD22 entries, and no SU53 errors. The same users worked fine in ECC, but now entire datasets appear invisible.
The real reason for failure.
This failure is caused by a shift from program-based to data model-based authorization. 1. ECC relied on explicit authority check statements. 2. S/4HANA enforces authorization at the CDS layer using DCL. 3. Authorization logic moves from ABAP code into data models. 4. Missing or incorrect DCL silently filters data. Here is ABAP code showing classic program-based authorization. Disclaimer: always test code in a non-production environment. Here is the traditional ECC approach. Authorization is checked explicitly inside the program logic. Here is ABAP CDS authorization using data control language, DCL. Disclaimer: always test code in a non-production environment. Here is the DCL role definition. Authorization is enforced automatically at data access time, not in the program.
The fix, the interview-winning answer.
A senior architect treats authorization as a data model concern. 1. Understand that CDS access is filtered by default. 2. Define DCL roles for all exposed CDS views. 3. Align PFCG roles with CDS authorization logic. 4. Test authorizations using real business users. 5. Document data access rules centrally.
Follow-up 1. Why doesn't SU53 show errors in this case?
Answer: because the user technically has access to the program. The data is filtered out at the CDS layer before it reaches ABAP.
Follow-up 2. Can we disable CDS authorization checks?
Answer: yes, but it is strongly discouraged. Disabling checks defeats the security model and violates clean core principles.
Follow-up 3, curveball. Why do CDS authorization issues appear only after go-live?
Answer: because developers often test with SAP_all or broad roles. Real business roles expose missing DCL definitions.
Exclusive pro tip. No data often means authorization.
In S/4HANA, empty result sets are frequently a security feature, not a bug.
Scenario 52, background jobs after migration, when nightly processing stops working.
After S/4HANA go live, nightly background jobs either run much longer than before or fail intermittently. Some jobs complete successfully in test systems but time out or cancel in production. Business users notice missing postings, delayed settlements, or incomplete batch updates.
The real reason for failure.
This failure is caused by runtime and infrastructure changes that are invisible at the code level. 1. S/4HANA executes database operations differently, often faster but more parallel. 2. Legacy jobs were tuned for ECC batch windows and single-threaded execution. 3. Background work processes compete with dialog and RFC workloads differently. 4. Jobs that relied on implicit commits or timing assumptions become unstable.
Why this fails only after go-live.
During testing, background jobs often run in isolation or with reduced data volumes. After go-live, real business load, concurrent jobs, and interface traffic expose timing, locking, and resource contention issues that were never visible before.
The fix, the interview-winning answer.
A senior architect treats batch processing as a runtime design concern. 1. Reevaluate job scheduling based on S/4HANA execution characteristics. 2. Split long-running jobs into smaller, restartable units. 3. Avoid implicit timing dependencies between jobs. 4. Coordinate with basis to adjust background work process allocation. 5. Monitor jobs using real production volumes before final cutover.
Follow-up 1. Why do some jobs run faster while others slow down?
Answer: jobs that benefit from set-based database operations often run faster. Jobs that rely on sequential logic, commits inside loops, or heavy locking may degrade due to parallel execution and contention.
Follow-up 2. Should we redesign all background jobs during migration?
Answer: not all, but critical and long-running jobs should be reviewed. Focus on jobs with high data volume, financial impact, or dependencies on other jobs.
Follow-up 3, curveball. Why do some background jobs fail only during month-end?
Answer: because month-end increases data volume, locking, and parallel activity. These conditions amplify design flaws that remain invisible during normal daily runs.
Exclusive pro tip. Batch windows are a design artifact.
If your job design assumes a quiet system, it is already outdated in an S/4HANA landscape.
Scenario 53, LUW and commit work, when data becomes inconsistent without dumps.
After S/4HANA go live, business users report partially posted documents. Some records are updated, others are missing, and no errors are logged. Rerunning the same transaction produces different results. The system appears unstable, but there are no dumps or update failures.
The real reason for failure.
This failure is caused by breaking the logical unit of work, LUW. 1. ECC code often used commit work liberally without consequences. 2. S/4HANA executes database operations more aggressively and in parallel. 3. Commit work inside loops breaks transactional consistency. 4. Partial commits survive even when later logic fails. Here is a BAP code showing commit work used inside a processing loop. Disclaimer: always test code in a non-production environment. Here is the core issue. Each loop iteration commits independently, permanently saving partial results even if later processing fails. Here is a BAP code showing correct LUW handling with a single commit. Disclaimer: always test code in a non-production environment. Here is the correct placement. The commit occurs only after all updates succeed, preserving transactional consistency.
The fix, the interview-winning answer.
A senior architect treats LUW as sacred. 1. Respect the logical unit of work boundary. 2. Never commit inside processing loops. 3. Let the caller control transactional boundaries. 4. Use update function modules where appropriate. 5. Design for rollback, not partial success.
Follow-up 1. Why does this issue become worse on S/4HANA?
Answer: because parallel execution and faster commits make partial updates visible immediately. What was masked in ECC becomes obvious in S/4HANA.
Follow-up 2. What about commit work and wait?
Answer: it waits for update tasks to finish, but does not fix broken LUW design. It still commits partial data if used incorrectly.
Follow-up 3. Curveball. Why do LUW bugs surface during interfaces more than dialogue?
Answer: interfaces often process large volumes without user interruption, making partial commits more damaging and harder to detect.
Exclusive pro tip. 1 LUW, 1 business outcome.
If a business document can exist in a half-posted state, your LUW design is already broken.
Scenario 54. Retrofit strategy. When fixes disappear after go live.
After S/4HANA Go Live, business users report that critical fixes applied during testing are missing. Issues that were confirmed as resolved reappear in production. The development team insists the fixes were transported, but the behavior says otherwise.
The real reason for failure.
This failure is caused by misunderstanding the retrofit process during system conversion. 1. S/4HANA projects run ECC and S/4 systems in parallel for extended periods. 2. Bug fixes are applied in ECC while S/4 remediation continues separately. 3. Without a controlled retrofit process, fixes never reach S/4. 4. Transport logs alone do not guarantee functional alignment.
Why this fails under pressure?
Retrofit failures usually happen late in the project, when teams are rushing toward cutover. Under time pressure, fixes are applied directly to ECC or production without proper synchronization. The parallel landscape becomes a divergence trap.
The fix, the interview-winning answer.
A senior architect treats retrofit as a governance process, not a transport activity. 1. Define a clear source system for fixes after freeze. 2. Use retrofit tools or manual comparison systematically. 3. Track fixes by business scenario, not transport number. 4. Validate fixes functionally in S/4 before cutover. 5. Enforce change discipline during the final project phase.
Follow-up 1. Why don't transport routes solve retrofit automatically?
Answer: because transport routes move objects, not intent. A fix may depend on other changes that were never applied in the target system.
Follow-up 2. Should all fixes be done in S/4 after freeze?
Answer: ideally yes, but this requires strong governance. Without it, ECC becomes a parallel source of truth, which is dangerous.
Follow-up 3. Curveball. Why do retrofit issues surface weeks after go live?
Answer: because not all business paths are exercised immediately. Rare scenarios reveal missing fixes only after extended usage.
Exclusive pro tip. Parallel systems create parallel truths.
If two systems are open for change, you no longer have a single source of truth. You have a risk factory.
Scenario 55. ABAP unit tests. When green tests still allow production failures.
After S/4HANA migration, the development team proudly reports that all ABAP unit tests are green. Despite this, critical business scenarios fail in production. Management questions the value of automated testing when it did not prevent go-live issues.
The real reason for failure.
This failure is caused by misunderstanding what ABAP unit actually validates. 1. Many ECC-era systems had little or no unit test coverage. 2. Tests are often written to validate syntax, not business behavior. 3. Hard-coded test data ignores real data volume and authorization. 4. Passing tests do not guarantee runtime correctness. Here is ABAP code with no unit test coverage. Disclaimer: always test code in a non-production environment. Here is a simple business method with no automated test coverage. Its correctness is assumed, not verified. Here is ABAP code with a basic ABAP unit test. Disclaimer: always test code in a non-production environment. Here is the assertion. It verifies logic correctness for a single controlled input, but does not reflect real production complexity.
The fix, the interview-winning answer.
A senior architect treats ABAP unit as a safety net, not a shield. 1. Write tests that validate business behavior, not just calculations. 2. Use realistic data and edge cases. 3. Complement unit tests with integration testing. 4. Avoid false confidence from trivial test coverage. 5. Continuously evolve tests as business logic evolves.
Follow-up 1. Why didn't ABAP unit catch the migration issues?
Answer: because unit tests usually isolate logic from database, authorization, and volume effects. Migration issues often surface at integration and runtime layers.
Follow-up 2. Should we add ABAP unit to all legacy code?
Answer: focus on critical business logic and frequently changed areas. Blanket coverage is expensive and often low value.
Follow-up 3. Curveball. Why do some teams abandon ABAP unit after go-live?
Answer: because poorly designed tests slow down change instead of enabling it. Tests must evolve with the system, or they become noise.
Exclusive pro tip. Tests should fail before users do.
If your unit tests never fail, they are probably not testing the right things.
Scenario 56. SPDD and SPAU. When the system is technically live but functionally broken.
After S4 HANA conversion completes successfully, the system comes up without dumps. Users can log in, transactions open, and basic navigation works. However, key business functions behave incorrectly. Pricing logic is missing, validations do not trigger, and custom enhancements appear to be ignored.
The real reason for failure.
This failure is caused by incomplete SPDD and SPAU adjustment handling during the sum phase. 1. SPDD controls dictionary object adjustments such as tables and data elements. 2. SPAU controls repository object adjustments such as programs and enhancements. 3. Unresolved conflicts cause SAP standard to overwrite custom logic silently. 4. Technical completion does not mean functional correctness.
Why this is a cut over killer.
SPDD and SPAU issues surface only after the system is open to users. At this stage, fixing them requires transports, retesting, and potentially business downtime. This is why many technically successful conversions still fail business acceptance.
The fix, the interview-winning answer.
A senior architect treats SPDD and SPAU as mandatory engineering steps, not optional cleanup. 1. Plan SPDD adjustments early during sandbox conversion. 2. Resolve SPAU conflicts before final test cycles. 3. Never postpone SPAU to after go live. 4. Document every adjustment with functional validation. 5. Freeze custom changes before final SPAU resolution.
Follow-up 1. Why doesn't some stop if SPDD or SPAU are incomplete?
Answer: because some validates technical consistency, not business behavior. It assumes the project team will complete functional adjustments.
Follow-up 2. Can we transport SPAU adjustments from one system to another?
Answer: only partially. Many SPAU decisions are system-specific and must be revalidated in each landscape.
Follow-up 3. Curveball. Why do SPDD issues often appear as data problems?
Answer: because dictionary mismatches can cause incorrect field lengths, missing fields, or conversion errors that surface only during real data processing.
Exclusive pro tip. Sum ends, responsibility begins.
If SPDD and SPAU are not clean, your go-live is only a technical illusion.
Here is the final scenario, the phantom update task, when data is written twice, or not at all.
After S4 HANA go-live, finance reports rare but severe inconsistencies. Some documents appear twice, others are missing entirely. Reprocessing sometimes fixes the issue, sometimes makes it worse. There are no dumps, no failed update records, and no obvious pattern.
The real reason for failure.
This failure is caused by an invisible interaction between update tasks and SAP HANA snapshot isolation. 1. ECC databases relied heavily on row-level locking with immediate visibility. 2. SAP HANA uses MVCC multi-version concurrency control. 3. Update tasks run asynchronously in a separate LUW. 4. Parallel dialog processes may read stale snapshots. Here is a ABAP code showing a classic update task-based posting pattern that breaks on S4 HANA. Disclaimer: always test code in a non-production environment. Here is the critical design choice. The update logic runs asynchronously in a different LUW, potentially on a different work process. This code assumes that the update task has already committed. On HANA, this assumption is often false due to snapshot isolation.
What actually happens at runtime?
The select reads an older snapshot of the database. The update task may still be running or not yet visible. As a result, follow-up logic triggers incorrectly, sometimes twice, sometimes not at all.
The fix, the interview-winning answer.
A senior architect treats update tasks as eventually consistent. 1. Never read your own update task results in the same dialogue flow. 2. Separate posting from follow-up processing explicitly. 3. Trigger follow-up logic via background jobs or event queues. 4. Use commit-dependent callbacks only when strictly required. 5. Design idempotent follow-up logic that tolerates re-execution. This answer shows deep understanding of HANA concurrency and LUW separation. Here is a BAP code showing safe event-driven follow-up instead of snapshot reads. Disclaimer: always test code in a non-production environment. Here is the architectural fix. Follow-up logic runs in a separate execution context where committed data is guaranteed to be visible.
Follow-up 1. Why did this work for years in ECC?
Answer: because classic databases exposed committed data more predictably and parallelism was limited. Timing assumptions accidentally held true.
Follow-up 2. Why is this issue so hard to reproduce?
Answer: because it depends on timing, system load, parallel work processes, and snapshot boundaries. It often appears only under production pressure.
Follow-up 3. Curveball. Why does adding commit work and wait make it worse sometimes?
Answer: because it waits for update tasks but does not change snapshot visibility rules. It gives a false sense of safety while increasing contention.
Exclusive pro tip. Update tasks are not sequential logic.
If your business logic depends on reading the result of an update task immediately, the design is already broken. S/4HANA just makes it visible.
Final thoughts. This was not a tutorial.
This video was not designed to teach syntax, shortcuts, or isolated tricks. It was designed to show how real SAP ECC to S/4HANA projects fail, quietly, expensively, and often without dumps. Every scenario you saw was a real failure mode observed in production systems. If you understood why each failure happened, not just how to fix it, you are already operating at an architect level. Syntax can be learned quickly. Judgment cannot.
What actually changes in S/4HANA?
S/4HANA does not just change tables or syntax. It changes responsibility. Developers are no longer protected by the database, the framework, or lucky behavior. You are expected to write deterministic, scalable, and future-proof logic every time. Most failed projects were not caused by bad developers. They were caused by good developers using the wrong mental model.
How to use this video.
Do not watch this once. Bookmark it. Revisit individual scenarios before interviews, design discussions, or critical remediation work. This is meant to be a reference guide, not background noise.
If this video helped you,
1. Subscribe for deep, failure-driven SAP content. 2. Share this with your project team before go live. 3. Use these scenarios as talking points in interviews. 4. Return here when something breaks in production.
what comes next?
This same reference grade approach will be applied to other domains: SAP Basis, FICO, MM, and real-world cutover strategies. The goal is simple: fewer surprises, fewer late nights, and fewer career-damaging failures. If you want to stop reacting to problems and start predicting them, you are in the right place.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S/4HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links. For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.